And this posted. Don't live stream yet on see this
Your audio sound.
for this one. It's mute now.
Your that meeting.
This not cool.
You want to see screen? You want to see screen?
For my WhatsApp, yes. I don't like this one. Okay, seven.
This one.
Was that person? Sometimes I won't able to change that code. I want this one to stand out of the phone. Maybe it's maybe it's
No, that's only before any seats.
Good morning, everyone. Can you hear me? Good morning, everyone. Audio not clear. Can you hear me now? Can you hear me? Okay. So confirm to me that you can see my screen. I want to share my screen. Can you see my screen? Can you see my screen? How about the audio? And the audio? The audio clear now. Let me check those on the live stream. Hello, can you hear me? So the audio, are you saying the audio for the screen I was sharing, is that the one that is bad? Is that the one that is bad? The volume is at the maximum from my end here. So I'm checking the sound. Which audio is bad? Which audio is bad? Is it the one for the facilitators list that I was just playing? The audio to the screen is bad. Like I'm speaking now. Can you hear what I am saying? Yes, I am speaking now, but that was the facilitators list. Okay, let me see. There were some videos, the photos we took yesterday. So we are taking the systems. Let me play this one and see. Tell me what this one is saying. Hello, everyone, and welcome to day 3. It's exciting to see you all today. How are you all doing? I hope you all had a well-rested night. It's good to see you all. So today, I am going to allow 50 people in. Once we have 50 people in, every other person will join via the live stream. So we have 38. In the meantime, those of you who are the early risers, we can take some few minutes to introduce ourselves and talk about how the journey has been for you so far. So we'll be doing that within 10 minutes. And once the 10 minutes is up, I will start the day's, you will start the day's lessons. So if you are in here now and you would like to give your feedback, verbal feedback, you'd like to talk about the journey since day 1 and to this day, it's that time and you get the opportunity. You also have questions that were not dealt with, or because you couldn't make it down into the Zoom class, you should raise your hand and I will unmute, or I will ask you to unmute so you can talk. So I am in the, if you would like to share your feedback on the journey so far, I'd like you to raise your hand. Use the raise your hand icon to indicate so that we can take your feedback on the lessons you've been taking so far. And I understand that the network has been, yesterday the network was terrible, but then I believe that students who will, that solution provider to the issue of network fluctuations that disrupts communication, those solution providers are in your classrooms. They are in our classrooms. It's a delightful thing to know that you are committed to your personal development. So in the chat, today we are only admitting 50 people into the room. Once we have 50 people, we are not going to admit anyone else. So I'm in the comment box. I'm also looking out for you to raise your hand with the icon that indicates that you are raising your hand. Anyone? Anyone? Can you hear me? Have any question? Have any? Have any? Anyone? Let's use the reaction. Let's take, this is 11:05 and nobody has said anything. And we are admitting people into the Zoom room. If you are in this Zoom room, even our folks on the YouTube live chat, they are Okay. Emmanuel Ruth says, I must say the journey into the space science has been facilitating and awesome. So that's Emmanuel Ruth. I want to know how the journey has been for you. There's no room for wastage again. I think those of us who made it into the Zoom room, we should engage. But if you are not engaging, then I will just go to the YouTube live stream and see. I want you to, we are taking time to talk about what the journey has been for you so far since you started this space education thing. How has it been for you? How has it been for you? Share your experience. Share your experience. Mr. Oyegun, right. Bàbá Ìkálẹ̀. Ìkálẹ̀ ni kẹ́ fi sọ o. Oh yeah, I'll mute so that you can speak.
Ṣé ẹ tẹ̀ dá mi mọ̀? A máa dá mi mọ̀ nàtànákè.
Bàbá Ìkálẹ̀.
Ẹ káàárọ̀.
Ẹ káàárọ̀ sà.
Ẹ lè gbọ́ ìkálẹ̀ wà fún bá sọ Yorùbá ọ́, mo bá sọ ní.
Ẹ kọ́kọ́ sọ ní Ìkálẹ̀ náà, then ẹ wá sọ ní English. Ẹ sọ ní Ìkálẹ̀, ẹ sọ ní Yorùbá, ẹ wá sọ ní English.
Ẹ jẹ́ kọ́kọ́ bẹ̀rẹ̀ English.
Okay, ẹ sọ English.
Lákọ̀ọ́kọ́ náà, I think the journey just unveil some reality, the values or the essence of teaching, especially the application of mathematics to students. Like I'll tell students that you see last month or some years ago, when they were asking me importance of bearing and distance, I said this is most of what the engineer usually use when they want to build maybe a hospital between 3 towns to serve one hospital to serve the 3 towns. So the journey just tell us more particular things. Maybe for example, you ask some students to go out to check some towns, giving them some map to look at the spaces. So in Yoruba, ìrìn àjò náà ó kàn sọ fún wa nípa bí ìwúlò ìṣirò ṣe rí ní ayé àwọn ọmọ. Kó má jẹ́ pé wọ́n kàn tẹ calculator, wọ́n kàn ka 1, 2, 3 nìkan. Kì í ṣe ká kàn lọ sí school ká lọ kọ́ nǹkan nìkan lásán. And nǹkan tí mo kàn lè sọ ní ìkálẹ̀ ni pé á jẹ́ jàrán ọmọ jàmà ìṣe ìwúlò ìṣirò ṣe rí ní ayé olúkálukú ní àdúgbò tàbí ìlú. So ìrìn àjò náà tí ìjẹta wá ó jẹ́ ìwúrí fún mi gẹ́gẹ́ bí olùkọ́. Ìṣèmọ̀ tí a jẹ́ kí class yàrá fún àwọn akẹ́kọ̀ọ́ mi jí inú wọn lè dùn pé yes, èyí iṣẹ́ tó bẹ́ẹ̀ kọ́ kínní inú kan but ó ní iṣẹ́ pàtàkì yóò fẹ́ ṣe ní ayé wa, yóò jẹ́ fẹ́ ṣe ní àyíká wa. So that is just I want to say.
Awesome. Okay, awesome. Thank you. Thank you for your feedback. You know, that is the essence, how we can link what we are teaching and make it adaptable, how we can adapt it to real world life situations. That is the way they can provide solutions. Someone says it has broadened my knowledge about space science. Words I have not heard before, like hydroponic. I heard that from my students when we were asked to come up with student projects for them. So the boy just came to me and said, there's something about hydroponics. I said, okay, go and read more on it. I heard that word for the first time from a student. That tells you that our students, yes, some of them may have very repulsive attitude, and they can make one upset. But we need to look beyond. They are like raw materials, and God will grant us the strength to bring out the best in them. Microgravity, yes, these are real life, real things. Right, thank you. So I will be starting today's program, and what I'll be talking about space clubs. So tell me, what do you think a space club should be? How do you get started? I'm waiting in the comments. What do you think a space club should be? And how should we get started with it? In the comments, reading your comments. What do you think a space club should be? And how do we get started? Talk to me. What do you think a space club should be? And how should we get started? Is somebody speaking to me? Let me see what's folks on the YouTube live stream. You are amazing. I love the way you engage. Your energy is just awesome. So keep chatting. We're going to be talking about Space Club. What do you think a Space Club should be? And how should we get started? Anyone talking? What should a space club be? And how do we get started? See, these are practical ways to engage your students. When you get to class in the morning, you don't just start. You are not the custodian of knowledge in this new dispensation. Madam Know-it-all. You dare to even learn, because I tell you, many of these students know more than we do. Like I told you, I heard of the word hydroponics from my students. So someone says from the YouTube live stream, yes, I'll read from the YouTube live stream first, then I'll come to us here. So here is someone says, it should be a club that researches and attempts to discover space travel and the technology that supports it. Awesome. How do we get started? Agbaje Daniel says, get a group of students, explain the concept of space club to them, and we can just get started. Banjo Deborah says, a space club. Let me read that. So I've taken to, I just saw Banjo Deborah's Okay, that comment has moved up. A space club should be a club established in school to provide students with the knowledge of the world around the planet Earth. The essence is for awareness of our surroundings. I think a space club should be where they discuss space activities like space activities, life and survival in space. Okay, awesome. Well done. One more. Starting the space club, Taiwo Joseph says, starting the space club in school shouldn't be a problem, just that the teachers to coordinate the club should be equipped with enough materials to help the students develop interest in the club. And that's what we are doing. So when you fill the form to indicate your interest in being a coordinator of the space club in your school, we will also take you through a series of trainings, and we will have we'll guide you so that it will be easy for you, right? A space club is a co-curricular gathering that brings information and discovery about space exploration and technologies. Well done, everyone. So I'm going to share my slides now. If you can see my screen, you confirm to me, please, that you can see my screen, and also let me know that you can hear me loud and clear. Can you see my screen? Can you hear me loud and clear? Can you see my screen? Can you hear me loud and clear? Let me check that you can see my screen and you can hear me loud and clear. Very good. What about my screen? What about my screen? Can you see it now? Right. So let's move on. So let's talk about space in the classroom, Educator's Guide to Launching Space Clubs. For those of you who are novice and you are wondering, what is all this space thing they are talking about? I am an educator just as you are, my distinguished noble colleagues, and this lesson is prepared to help you get started with launching space clubs in your schools, classrooms. So your mission to space, and this is an activity I want us to carry out. NASA has just selected your crew to embark on a mission to Mars. You have to choose 3 essential tools / technologies to colonize your colony. Identify 1 key skill each of you brings to the mission. Decide on 1 scientific experiment you will conduct on Mars to help humanity. So that is an activity you are going to carry out for, you have 3 minutes to provide your response. Think through it, get a sheet of paper around you, and imagine that NASA, the National Adeola Akinsulure told us the full meaning of NASA. By now, you should know the full meaning of NASA. Has just selected your crew. Your crew is you and your students to embark on a mission to Mars. You have to, number 1, choose 3 essential tools or technologies to colonize your colony. Identify 1 key skill each of you brings to the mission. Decide on 1 scientific experiment you will conduct on Mars to help humanity. So are you chatting? Are you chatting? Are you chatting? So you have 3 minutes. Think about it. Think about it. and provide answers. Very good. So you have 2 more minutes to brainstorm, and you have 2 more minutes to brainstorm and provide your answers in the chat. I'm waiting for you. So in my class, if I get to class, I don't just go ahead and start talking. If I ask them questions and they don't answer me, Ajomama Wurawani, I'll be looking at you and the time will go. So provide your response to the question. Okay, the question is, NASA has just selected your crew to embark on a mission to Mars. You have to choose 3 essential tools / technologies to colonize your colony. Number 2, identify 1 key skill each of you brings to the mission. Number 3, decide on 1 scientific experiment you will conduct on Mars to help humanity. Yeah? Are you with me? Are you with me? So what do you say? Let me see what we have in the chat. Somebody says 3 essential tools: oxygen, life jackets, and helmets. Another person says sending a robot that will what now? Sending a robot that will collect the samples on Mars for analysis. What about key skill? Somebody says jet plane, and oxygen. Somebody says oxygen and water. What do we have here? Oh, well, so there you go. You think about these things. So these are called these are questions you should, whenever you start your classes, you start by asking questions to stimulate the minds of your students to think. That question has then 3 children, isn't it? Just like in WAEC, where we have children and grandchildren for a question. So asking those questions are known as open-ended questions. And they will help your students to think critically, to think creatively, to think about solutions. Are you with me? Right? So as we progress in the training, we are showing you practical ways to reproduce what you are learning here in your class. Let me just briefly introduce myself. My name is Oluwabanke Adewusi, and I am an educator like you. I was selected as part of 10 Nigerians to participate in the Limitless Space Global Educator Program. And we were We went to Houston, Texas for a 1-week summer institute. That's me. That's me after a 1-year professional development training and the wealth of knowledge I gained from the training, which was a whole year-long training, is what I am sharing with distinguished noble colleagues in Lagos State and globally, so that no child will be left behind. I obtained a bachelor's degree in biochemistry from the Lagos State University, a master's of science degree in biochemistry, and a doctoral degree as well. And I am an education officer, and I help my learners achieve their learning goals by breaking down hard concepts into simple, easy to understand learning points in a fun, engaging, and learner-focused atmosphere. I am a passionate educator who believes that education is light and education is the solution that we need for our national development, prosperity, and freedom, ultimately. So the objectives of my presentation are to help you understand the importance of space education, learn to set up and manage a space club. We will explore activities and resources to engage students and network and collaborate with fellow educators in our Space Club coordinators community after the training. Don't hesitate to place your questions, drop your questions as we go on so that I don't forget. Ask questions, okay? So why space education? Why is it important? Why is it important? Why is space education important? Who can tell me? Why do you think space education is important? Somebody talking? I'm waiting to hear from you. Why do you think space education is important? We will continue this shortly. We'll continue this shortly because our first speaker is around. So I'm going to have to pause my presentation to let her in. I'm going to pause my presentation. Our first speaker is Jenny McCall. She is coming right in. You all know Jenny McCall. Jenny McCall is in here with us. So, hello, Jenny. Welcome. You can unmute.
No, I can't. Hey, there I am. Can you hear me now?
There you are.
Yay! Good morning. It's
Good
so good to be
morning.
here. All right, I'm going to go ahead and share my screen. Here we go. Can you all see?
Yes, I can see. Let me
All
see.
right. Well, I want to go through an engineering design challenge that I do with my students in the classroom. And I want you to think about if there's any materials in this activity that we need to change or adapt for Nigeria. I want you all to give me feedback on that, how we could make it even better for your classroom.
Then one thing, please, before you continue, Jenny. Jenny,
Yes.
please speak slowly so that we can hear you. Don't talk fast.
Okay, thank you so much, Banke.
You're welcome.
So I'll say that one more time. This is an engineering design challenge that I have done in my classroom, and I would like you all to think about doing it in your classroom and give me feedback about what materials may work better in your class. And I'm hoping you all have the ability to type in the chat questions or ideas as we go through this. Just to show you who I am, my background, I thought I wanted to teach high school students, which here in the States would be like 14 to 18-year-old students, chemistry. And so that is how I got my teaching certification. But one year we moved very late in the summer because my husband was going back to school. And I got a job in a middle school teaching 12 to 14-year-olds. And I fell in love with that, and I've never changed. So I've always been, for 17 years now, a 6th and 7th grade science or STEM teacher. And right now I teach in Kentucky, and I teach in what is called a Title I school, which in the US means our school has been recognized for poverty, for having students that come from homes with not as many resources. And so the government gives us some extra teachers in our school, some extra resources to try to help students have a fair and equitable education. My family is the most important thing to me in the world. I have 4 children, and my oldest son got married. My husband is teaches in a seminary, and actually he has been to Lagos to work in one of the seminaries there. And then these pictures are just showing you some of my favorite experiences over the last few years. From working in my school with my students to going to space camp. I know you heard from Lauren Parker on microgravity. I was able to fly experiments, and I have a little bit more to explain to you about that. And then there's a picture there of me on a NASA mission called Sophia that has an infrared telescope, and you fly through the night, and it partners teachers with NASA scientists. So that was a really exciting opportunity. And then, of course, Limitless has been one of the highlights of my teaching career, not just what it has taught me, but getting to partner with the teachers in Brazil and the teachers in Nigeria. It's just been an amazing experience that I don't want to end. So our challenge today in the next 25 minutes is to think about when we launch astronauts to the moon again, how will we get the rocket from the building that it's being built in? So this picture in the middle is down in Florida, and it's called the Vehicular Assembly Building, or the VAB. But you notice it's 4 miles away from the launch pad, which is pictured here. So how do we move such a heavy rocket over such a long distance? The answer is NASA has 2 transporters that are called crawlers, and they're massive machines that are built to move rockets down from the building to the launch pad. And they're some of the heaviest self-powered vehicles in the world. 6.6 million pounds, but they only move at a speed of 2 miles per hour because they're moving such heavy loads. So what we're going to task your students with, and what I've asked my students to do, is to build a crawler on their desks or on the floor, and it has to be strong enough to move the most weight, but it has to be lightweight enough to be able to move. Sometimes students want to tape it to the table, and you can't do that because it has to be movable. I will go ahead and show this video for a minute, but if the sound isn't working well, we will just skip over it, okay? But this
We're taking off from the Kennedy Space Center, our multi-user spaceport. I'm Yves Lamoth, and we're cruising on the Crawler Transporter 2. With us today is John Giles, the Crawler Transporter project manager, here to tell us a little bit more about the crawler. What exactly is the Crawler Transporter used for?
We will take the launch vehicles out to the pad and the ML and whatever anybody asks us to. And we've been doing it for over 50 years. Everything that's launched from pad 39A or B rode out there on one of our 2 crawlers.
So the Crawler Transporter is massive, and you said it goes at a top speed of 2 miles an hour. Is it because of how heavy it is? How much does the Crawler Transporter weigh?
So the crawler itself weighs about 6.6 million pounds, which is actually kind of small compared to we carry things that are 10, 12, 14 million pounds. So what we'll do is we'll travel underneath something. We'll go underneath it, we'll pick it up, like the ML, for instance, with a launch vehicle on board, and we'll jack it up, we'll take it out, we'll drop down to our cruising level, and then we'll go out to the pad on top of a specifically prepared crawler way, which consists of about 1 foot of rocks, and then below the rocks are about 4 feet of hydraulically compressed limestone, and then below that is many feet of sand that's been compressed to support all of our weight.
Another question is, how do you see in front or behind you with how big the Crawler Transporter is?
So we will actually have a team of about 20 personnel that go with us the whole way out there. That'll either be on board or walking alongside, and everyone will be on radios and in contact with each other, and the driver will frequently say, hey, somebody on the other side of the crawler, tell me how close I'm getting to this. So we have eyes all over it.
So one of the things that I've noticed is the pad.
okay.
It's
So
lost
if you,
audio.
We're taking off
I
from
was
the
going to
Kennedy.
stop there because I just wanted to give you guys an idea of what it looked like in motion. If you want to watch the rest of the video, you can, but I definitely wanted to have time to get through all of the presentation, and I was hoping to have some engagement and interaction with you. So what your students are going to do is they're going to build a platform on their desk or table out of some simple materials. And again, it has to be light enough to be moved to the launch pad, but strong enough to hold the weight of the rocket. So here are the materials that I used in my classroom, and I would love you guys to chat if you have the availability to respond to me by the end of this presentation if you think any of these materials would need to be changed. I put my students in groups of 2 and gave each 2 students 20 straws, a pair of scissors. I gave them pennies, but I don't know if that would work well in Nigeria. You could also use small bolts or something else that's a small metal mass. And the reason I used pennies is I don't have a lot of weights in my classroom. So for me, this was an affordable way for every group to add weight to their rockets. And each penny weighs 2 grams. I gave each group 60 pennies, you can see here. and then they have a cup. They get a 3x3-inch piece of cardboard. And then I just gave my students masking tape. You will see there's a NASA educator guide that goes with this lesson. And they said you could also give clay or Play-Doh if you're working with younger students. And then this little picture here is the rocket that we'll print out, and you'll see in just a moment that that is going to get taped to the cup. If there is a tie, or if there's two groups that both hold the same amount of weight, the way we decide the best design challenge is we weigh both of the platforms or both of the crawlers, and whichever one weighs the least on a balance, if you have it, that's how we decide the winning design. Now, one thing I did with my students here was connected to engineering as they did this challenge. So 4, possible connections would be looking at chemical engineering, electrical engineering, mechanical engineering, and civil engineering. And when I click on that, and I'll give you this presentation in just a moment, this is going to link students to a NASA tab. And there's a brief video there. And then there's some reading for the students to do about those 4 areas of engineering. So just a little bit of a career connection that you can add to this challenge. So one thing I asked my students to think about was I took an item that was in my classroom, and this might be different for you, but in my classroom, students have a pencil and they're required to bring a pencil to school. I, of course, have extras I give to anybody that is missing one, but I asked them to think, because they can hold it in their hands, what materials make up a pencil? And the students will come up with, there's wood, there's metal, there's rubber in the eraser, there's graphite in what we write with, and that helps them to think that materials science is all around us. So taking that same question and thinking about our design challenge, what materials would be needed to build the rocket, to build the spacecraft? Right here, Orion, that is at the very top of the rocket and holds the astronauts, and specifically what's in the crawler. What material would the engineer be interested in that would be strong enough to hold the heavy rocket, but lightweight enough to be transportable? So students are then given a brief paper that asks them to think about what is one thing that is made from aluminum. And then they're supposed to name 2 things that are light but also strong. And they have to draw a picture. And in my class, I always tell them, if you don't take time to think about your design before you share with your partner, your design will not be as effective or as strong, because thinking time is where we take our creativity from our mind and we organize it in our notes. And then when we partner up with a partner and we share our sketches, we have double the creativity. And you could even put students in groups of 4. But I think it's very important to give students at least 15 minutes where they're not allowed to talk. They just have to think and draw their design, make notes on it about what materials they want to use, and then they can pair up with their partner and discuss their idea. And finally, we move into students' favorite phase, and that is building. So you can see in my picture here, this is Ava. We just did this activity about a week and a half ago. And you can see in the picture, this is that rocket that I've printed out for her. She taped it to the cup. She's making a simple platform. And we're going to go through these rules one by one. So the first rule is each group's launcher platform will be tested by placing the cardboard on top of the platform. And students can tape that to their design. And then the cup with the rocket taped on it represents the weight of the rocket. We added 1 penny at a time in the cup. Each penny is 2 grams. So if it held all 60 grams, that's 120 grams. But you'll see in just a moment, my students did way better than I thought they were going to do on this challenge. So we went way over the 120 goal that I had for them. Now, one of the challenges that we haven't talked about yet, and you can see in the picture, I do give them a ruler. They have to build the platform so it's 6 inches off the ground. Like you saw in the video, the real crawler is tall enough that a person can walk under it. It has to be clearanced off the ground so that it doesn't get caught on anything as it's moving to the launch pad. And then here are some designs from my students here. Here's Serene and Lucas on the left, and they built their platform. You can see the rocket on the top, and they had a really good time with this. They were very excited to test it. Over to the right, I've got Josie and Donna. They're not done with theirs. That picture was taken while they were in the middle of their build. And then in the middle, this was the second place winner, and it held 600 grams. Once we got to groups that had held the 60 pennies, in my classroom, I had hooked weights, and those weights each were 240 grams. And so I started adding hooked weights, and you can see in this picture that my arrow is waving over. There are 3 large black hooked weights and pennies, and that was the winning design. It held 840 grams. Now, I asked all my class to look at these 2 designs. The larger picture is second place. The smaller picture is first place. And I asked them, what do you notice about these designs compared to some of the others in the classroom that helps us understand why they were the top 2 designs? Are you able to comment in the chat and tell me what you notice about these pictures that might have led to them holding the most weight?
So I mean, the comments, I will read the comments out to you as soon as I'm seeing them.
Thank you so much. If you look at the table, what do you notice about how these students built their base? Because that's a secret to you. If you do this in your classroom, what makes a better design? I'm going to wait just a minute to give you some thinking time. Well, one thing that my students said is they said, Mrs. McCall, they built their base bigger. And that is the key. So you can see if you look at this one to the far left where my cursor is, it's a small square base about the same size as the weight that they're trying to lift. But if you look in the middle, we have a larger rectangle compared to the smaller square cardboard. And then the design that held the most weight, you can see it has a very large square to support the smaller square. And that is a big secret to how I would never tell my students that ahead of time. I would let them learn from what doesn't work. But these two groups did a really good job. And that's why I wanted to show the picture to you. Now on slide 14, if you click this picture, it'll take you directly to the educator guide, which I'm sharing with you. And you can see as you go through, this is your instruction book as a teacher that tells you what materials I need, what standards it covers, and then step-by-step directions. What do I need to do as a teacher? So how to be prepared, some background information, how to introduce the challenge. If I have spoken too fast, I've tried to slow down, but I know it still might be hard to understand. This guide will take you through word for word how to do this challenge. And so you can see right now, discussing, the results. That's what we just finished. Here is the paper if you wanted to print that out for your students. And on the back of the paper, the next page is where they make their sketch. And then I haven't shown you this yet, but now there's some reflection on what they did. So they have to ask themselves, did you use all your materials? Yes or no? Did you change your design as you were building? You made a sketch or a drawing. Did you actually build what you drew, or did you change it? And if you did change it, why did you do that? Students are supposed to estimate how many coins or how many weights do you think it will hold? And then they also write down how many did it actually hold. And in my classroom, I had so many students that it held all of the pennies that I gave them. That's why we moved on to adding more weight. And you could use anything. It wouldn't have to be a hooked weight, but you could use anything you have that would add more weight, and that you could use the same with each of your student tests. And then it asks them, if you did this again, would you change your design? And then why? There's some pictures of this rocket to compare it to other rockets, or to compare it to the Statue of Liberty, just to give students an idea of how big that is. Some fun facts. And then this is where you get that printout of the rocket. You print it out and then you cut it out and tape it to the cup. And they even include at least a second picture. And you notice the Space Launch System rocket from NASA is built with two different cargo bays. And if students ask, well, why is this one so much bigger? This one is designed to carry more materials to the moon, because in the Artemis mission, we're going to be building a station that's going to orbit the moon, similar to how the International Space Station orbits our Earth. Now, I'm going to take 1 second here and share this link with you in the chat. This is my presentation. And then I'm looking at you did give me the answer. The base is bigger. I see your comments. Way to go, guys. And then I'm loving the feedback, because that's my next question. Let me go ahead and move on and then come back to your comments. The next slide is asking you, what materials do you think we would need to revise or change in Nigeria? If you were to do this in a space club at your school, or if you were to do this in your classroom to teach space education, what would we need to change? And I'm reading your comments. I think a cardboard, a paper tape, and straw for a bottom stand for the base are the materials used for the base, which makes it bigger than each other. Okay, awesome. You guys are still answering my last question, which is fantastic. Does anybody have anything to add in the chat? Do you have access to all these materials in your classroom, or what materials might need to be changed? No coins. Okay, I was wondering about that. What could you use as a weight? Could you use like dried beans? I've used that before. What do you think would work well for weights in your classroom?
What do you think would work well as weights? You also have, let me see what they are saying.
Someone is saying, could slotted masses be used? Absolutely. If you have those in your classroom, that would be wonderful. And that is what I ended up using for the final two. You would just have to test them one by one unless you have enough weights, to use in your classroom. I had 16 groups building at the same time. And so that's why I gave them something small so that was like the first test. Who can pass adding the coins, because they could weigh it at their own table all at the same time. And then I see someone saying a pendulum, that would absolutely work too. But again, you'd have to go one at a time. I love Emmanuel says, what if we had the same size of stone? That's a great idea, because then you could have multiple groups weighing at the same time. This has been so fun to go over this with you. I shared my presentation with you. I know I'm out of time, but if you want to look at the experiments that I did with my students, and the lessons are available to you when I flew in microgravity, I included those slides here. And let's see, what slide am I on? Slide 17. There's a whole bunch of activities you can click on for your classroom and videos to learn more about how liquids behave in microgravity. And then here are the 3 lessons. And you'll notice on all of these lessons, you can click on the YouTube video and see my experiment. And this, my 3rd lesson, didn't work so well. So I would recommend you use the NASA guide from Krista McAuliffe's Lost Lessons. I linked that there. And these are really fun to see how a pendulum works differently in the moon's gravity versus Earth's gravity. And the next slide will show you in Martian gravity versus lunar gravity. Let's see, we've got 1 minute left. That was just a write-up the day after the experiment. And then these were some other researchers that were on the same plane as me, just to give you a feel for what it is like on those zero-G flights. And I hope this is a fellow teacher that said this saying, and it summarizes how I feel about being a teacher. I'm not an astronaut, but I love being a teacher. And I think I still get to do extraordinary things with my students. And if you have any questions, I would love to connect with you. So please do reach out. Oluwabanke, thank you so much for asking me to join you today. It has been a real privilege to be here today.
Thank you so much, Jenny. We have learned loads. Like, if you could take 5 minutes to answer questions. Let me quickly check if there are questions on the WhatsApp, on the YouTube live stream. Okay. If there are any questions going forward, I can always mail them to you and return your responses to them. Thank you so much, Jenny. We appreciate you for taking time off your busy schedule to do this. God bless you.
Yes, and I just put my email in the chat. Feel free to reach out to me anytime for anything I can do to help, okay?
Yes, please. Thank you.
Bye-bye.
Cheerios. Thank you. Oh, wait, 1 minute before you go. Jenny. Hello, Jenny. Before you go, you can unmute.
Now I can. I'm back.
Okay, hold on. We would like to take a group picture in here.
Yay.
Yeah, so I love this part a great deal. So we'll do hold it on, hold on. 3, 2, 1. Taken. I've sent it to you on WhatsApp.
I love it. Thank you so much. Have a
You're welcome.
wonderful day.
You too. Bye.
Bye-bye.
All right. Moving on. You are right on time. We have Mrs. Rashidat Ademosu. Mrs. Rashidat Ademosu is one distinguished teacher, and her profile is so impressive. We have amazing people doing amazing things, but I will read the profile to you later on. But right now, we need to get down into the business of the day. So we welcome Mrs. Rashidat Ademosu. I just let me take a little time to tell you a bit about Mrs. Rashidat Ademosu. Mrs. Rashidat Ademosu is a basic science teacher who is dedicated, and she is an innovative educator known for her significant contributions to various educational initiatives and programs. She actively promotes global education initiatives, encouraging students to engage with international educational standards and practices. She leads the school's robotics club, fostering students' interest in STEM, science, technology, engineering, and mathematics through hands-on projects and competitions, mentors students in the JET Club, guiding them in scientific research and engineering projects that enhance their problem-solving skills and creativity. She plays a pivotal role in the Limitless Global Educator program, where her students participated in projects that were transported to the International Space Station. Her leadership in this program has been instrumental in showcasing the innovative spirit and academic prowess of our students. Under her guidance, students have excelled in various STEM competitions, including a notable victory, I beg your pardon, including a notable victory in the microgravity experiment contest. Mrs. Rashidat believes in the transformative power of education and is dedicated to providing our students with opportunities to explore, innovate, and excel in their academic and personal lives. Her work continues to inspire both our students and colleagues, making her a respectable figure in the educational community. Ladies and gentlemen, distinguished noble colleagues of the Center of Excellence, kindly make welcome Mrs. Rashidat Ademosu with a resounding ovation. Give her a, use the chats, those emojis and reactions, make welcome Mrs. Rashidat. On the live stream, Please make welcome our distinguished Limitless Global Educator Ambassador. We are so honored to have you join us, ma'am. Welcome. Let me ask you to unmute so that. Yeah, welcome, ma'am. You can unmute, yeah. If you are speaking, we can't hear you. Have you unmute? Yes. If you are speaking, we can't hear you.
Hear me now?
Yes, I can hear you now.
Okay. Good afternoon, everyone.
Good afternoon, ma'am.
I'm happy to be part of this session, and I want to say kudos to you because I'm sure this has not been an easy task. But it's a good thing we are coming together as educators to improve on ourselves. So I'm happy to see us again. Am I sharing my screen already?
Let me see. Yes, it's coming up, but it hasn't shown yet, but it's showing now.
Okay. So can we all see my screen?
Please put it on slideshow.
I want to be sure if
Yes, I can see your screen. Now it needs to be on slideshow.
so can you see it clearly now?
Not yet, please. Okay, is this from your phone?
No.
Click on presentation view.
Can you see it now?
Yes, please. It's clear now.
All right, thank you. So good afternoon once again. My name is Rashidat Ademusu, a science teacher from Lagos State, one of the Space Global Educator, and I'm happy to be here today. So I would not want to take much of our time because I want to believe some of us have been here since 10 o'clock and we need to have a little form of exercise because we've been sitting down for long. So I'll start my presentation with this icebreaker. And the question is very simple. I just need us to represent this picture with just one word that we think is best for us to represent these pictures. So let me okay, I can see old class teaching, 21st century teaching, learning. Yes, collaboration. Okay, teaching and learning processes. That's more than a word. Just one word. Okay. From my own end, I'll say student-centered. Yes, what to some extent, teamwork. From my own perspective, it represents something like evolution or innovation or transition. Because when we look at the first slide, starting from the left, the teacher was actually using a chalkboard, a blackboard with a chalk. While the second picture is the use of whiteboard with a marker. Then it transits to the level of using a computer in the class. And later transformed to the use of projector in the classroom. And from there, we move to the use of interactive board or a glass board. And finally, we have the virtual reality. Now, all these pictures represent just one thing. That's the transformation in education. Sometimes we are at the first stage. Later, we move to the second stage, then to the third. To some of us, we are in the fourth stage now, to majority of us. While some have actually graduated to the fifth and the sixth stage. Now, the summary of all this is that this transformation didn't start in one day. It actually went through a lot of processes, and it took us some time before we actually got there. And I remember in 2007, 2006, 2007, when in Lagos State government introduced sexuality education into the scheme. You know, some people were against it, that it will make the student promiscuous, this and that. They came up with different allegations. But at the end of the day, it was incorporated into the scheme, and we had no choice than to use it. As an educator in Lagos State, you just have to teach that topic. If your subject falls within that category, at least for those people teaching basic science, social studies, civic, like that, you just have to teach sexuality education. So what we are trying to say in essence is that transformation is not something that starts overnight. It takes time. And this will lead us to my topic of presentation, which is integrating space science into Nigerian curriculum across all subjects. When we hear, are we hearing me?
Yes, please.
So when we hear the word space science, for most of us, what comes to our mind is about science, it's about STEM. If I'm not a STEM teacher, I'm not part of it. I'm not wanted in that area. But the truth of the matter is, every educator, every sector needs innovation. We need new things. We cannot continue to do what we have been doing over and over again. We need to add something to make it different from what we have been doing before. So my presentation is just going to be on how we can incorporate this space science of a thing into our curriculum. Be it a STEM teacher or not, we can always get something from it. Because from the previous presentation, I want to believe that somebody sometimes have discussed it with others. An astronaut cannot do without other people around him or her, because they can't do it all alone. Fine, to be an astronaut, you have to be a scientist. But at the same time, we need other people in that field that are not scientists. For an astronaut to go to space, somebody needs to plan. Okay, what would the astronaut be needing? What will it cost us to invest in him? If he's to go, how long will he stay there? what and what will he be needing, who is going to make the suit, the oxygen he will be needing, how do we get it, the food he's going to eat, how are we going to get food that can sustain him. You know, different people from different fields will be involved. They have to brainstorm, come together, and make the whole journey a reality for him. So the same thing comes to us as educators. This space science we are preaching
Hello, if you are
just
talking. The last
about
thing we heard,
self
can you hear me? The last thing
from
we,
it.
this space science
Yes.
we are preaching,
Okay.
yes,
I said it's not just about the STEM teaching, it's about all of us as educators. We need to contribute our own quota. The students we are teaching are all in one class. If we are teaching them together in one voice, they will realize that the era of I want to be a doctor is over. We need people in other fields. There are other salient fields that people are not looking into, especially for those of us in Nigeria. We need our students to change their mindset that if you are not a lawyer, you cannot be rich. If you are not a doctor, you cannot be known. This is an era of technology. And if you are into technology, you are limitless. You can be in any field and you will surely survive. Now, why do we need to integrate space science? Firstly, we need to do this to encourage curiosity. As educators, as parents, we know that while we are growing up, and we can see the same in our children, in our learners, as they are growing up, they are curious about things around them. We look at some of them to be naughty, to be unstable. But the truth of the matter is, rather than we allowing them to waste away their energy in an unnecessary things, we can always redirect them. Let them make use of that strength they are wasting away. Let us develop their curiosity, nurture it in such a way that it will be useful for them in the future. Science ignites and wonder about students to explore the world around. We have day, we have night, everything is changing, days are counting, months are counting. What is behind all these things? We can ignite that curiosity in them through our work. We also support development. Development is not just about I'm a physics teacher, I'm a math teacher. Like I used to tell my colleagues, we all in STEM. But for you to that, when I get my salary, I need to allocate to percentage to house rent, one to house leave, one to transport, to another thing. You are in STEM. Because all those involves mathematics calculation. And the engineering is come when you look at gas is best, what alternative method can I use to okay? Instead of taking um, what do we call now? Trice is another word. So we are all into this STEM that we are preaching. So we need to support it. If we feel that I'm too old, I cannot do it again. What about our children? What about our learners? We need them to be more professional. We need them to see the broader world, to enlarge their thinking. Let us bring the innovation in them. According to research, they said Nigerians have this ability of surviving in any other part of the world than their own nation. And I said, if you can live in Nigeria successfully, there is no way you cannot live. Because we understand the situation in Nigeria and we are coping, we are surviving. So for us to do that, we can still do better. What are the benefits and opportunities of space science integration? Firstly, we can look at it as enhancing STEM education through hands-on and inquiry-based learning, making learning more engaging. If you are teaching business study, for instance, now, and you are to teach cash, there's one topic, I can't really picture out the topic, but I know there's a topic under cash transaction or something like that, that you need your student to bring receipt, invoice, different kind of transaction documents like that. If the students are able to bring it and you actually guide them on how those things are used, you have ignite that idea in them that, okay, when you buy something and you are given a receipt, this is the essence of the receipt. If I need to go and buy something, I need to request for the receipt. So that if at the end of the day that thing is faulty, I will not go back to the person that sold it and the person will tell me, you didn't buy it for me, it's been long, is it that? There must be a warranty. There must be a kind of transaction document between the two of you that shows you actually bought that thing and the person gave you the assurance that it will work. On getting up, it didn't work. So you have the right to collect your money back from that person. But if we don't give them the idea of all these hands-on activities or things that challenge their thinking, they may not know. Not because they don't want to know, but because they don't have the privilege, they are not opportuned to know what is happening around them. But if you allow them to, which is one of the benefits of space science, there is no way you enter the class and you tell your students, do you know that when you look at the sky, we are actually seeing some of the planets? And they're like, wow, how is that possible? And you tell them, at night, just try to look through the sky and see whether those things you are seeing, is any of them moving or not. If they're able to locate anyone that is moving, that means that thing is likely to be one of the planets. And if you are lucky, you have a periscope for them to use, which is beautiful. They cannot wait to see, because the essence of what we are teaching is to relate it to real life experience. How does it affect them? So that they can understand that teaching them quadratic equation, teaching them reproductive system in science, teaching them about office is not just for teaching sake. Is the beauty of the whole thing is for them to relate it to their real life experience. Also, another benefit of space science is to provide career pathway in space technology, astronomy, engineering, and creating opportunities for skilled graduates. Regardless of your field, the world has gone beyond it's only if you study accounting that you can work in a bank. It's only when you study medicine that you can do this, that you can do that. Everything is interconnected now. You can study Yoruba language and work excellently in a financial institution because you have gotten that technical know-how that even an accountant, a graduate in accountancy, may not have. So to an employer, they will prefer somebody that will require them not to be trained or to give little training, than somebody they will have to invest a lot. So we need to let our students know that the workplace now, the workforce now is looking for people that are curious, people that are willing to go outside their comfort zone to learn. It's not just about, okay, I'm teaching basic science. Everything I'm working on should be about basic science. I should be able to do something in mathematics. I should be able to understand something in Yoruba. I should be able to understand something in art. If not everything, at least I should have an element of those traits because I was taught all those things along the line. And also, it drives technological advancement in fields like AI, satellite communication, robotics, and fostering innovation in various sectors. AI is the in thing now. It has come to stay. It has nothing to do with your field of study. Regardless of your course of study, AI is there for everyone to use. Your ability to use it in the best way determines how far you can go with it. So these are things we need our students to understand. And we as educators, we need to work around that whether we are, regardless of the subject we are teaching, it doesn't matter. Now we'll be looking at some of the subjects that we teach in school and how we can incorporate space science into them. For basic science and technology, which is BSc in junior school, already in our scheme, in the scheme of basic science, there are some elements of space science topics there. But I discovered some of the teachers do skip that aspect because of some constraints. Maybe because of the resources, they don't have resources to teach it. Space science is not something you can just be teaching the theory because you yourself have not been to space. So you cannot just be telling the children the stories. But there are activities that we can introduce to them. We can tell them to make a kite, and try to fly that kite and see whose kite will go farthest among them. Then we can try to design the solar system. Try to create video on different planets. What are their characteristics, especially our planet? What is the characteristics? And you see that these students they'll be motivated to learn, they'll be interested. When you are talking about Newton's law of motion, let's try and look at, okay, what experiment can I do with my students to convince them, at least to show them the reality of what I'm actually teaching. We can introduce concepts like gravity and planetary motion. Students or they mold something that represents the planet around them and we start moving it, explain how this is stable, is not moving, and all other planets are revolving around the sun. We can also use different materials to design.
If you are talking, we can't hear you temporarily. I guess the network. Can also use different materials to design. That's the last we heard. If you are talking, we can't hear you. I guess the network has struck again. Network can strike from time to time. I'm thinking that the network has interfered again. That's definitely network. That's definitely network interference, but I'm sure she will be back in no time. I'm sure a couple of your questions about how to integrate space science into different subjects are being answered during the course of this training, right? So let me, yeah, she's back. Please unmute. Please unmute.
Sorry, I just realized that I was out of the discussion.
Yes, I know. The network can sometimes strike. So
I'm so sorry for that. So where did I stop?
you were telling us that you can just ask them to design the sky, telling us about how to integrate space science into basic science and technology, for example.
Science. Okay. So I was actually rounding up on robotics, that for those of us that are not into robotics, we can just find a way of
You've not gotten
Are
to
we
the
seeing my
robotic
screen?
parts. No, it hasn't started sharing yet.
Okay.
You were still on integrating space science into different subjects, saying they should create a design of the sky.
Yes,
Before the
in
next.
basic science and tech.
Yes.
Sorry, I'm trying to share. I want to share my screen.
You can share it.
Are we seeing it now?
Not yet.
Are we seeing my screen now?
Not yet.
Are we seeing it now?
Yes.
Can we see it?
Yes. Yes. This was on slide 5. You were on this slide 5.
Yes, yeah. So I said, for those of us that are not into robotics, or we don't really have kits in robotics, we can just go online, create video, or get from the existing ones, and see how we can edit that video to be incorporated into our learning, our classroom teaching. So that, because sometimes when these children, when they see those things that they are not privileged to see, it makes them a better person. It makes them want to know more. For some of them, they have opportunity to the phone, but they never knew things like that exist. Let me give you an example. In my class one day, I discover that most of my students, when I want to get them, I just tell them, in Big Brother Africa, I be Big Brother Niger, there's this guy. I don't watch the program, I don't know anybody there. I'll just say there's this guy. They will tell me the name. Is it the one that is this? Is this the one that does that? So I just pick from there. And from my observation, I discovered that most of them are just engrossed in all these filthy things that is not adding value to them. So I how to go online on TikTok, look for video on science experiments, science illustrations, and I gave them the link that when you get home, I inform the parents, I inform the school authority, and inform the parents, allow them to use your phone, but you have to be the way they are doing it. Open that link and write the observation from that video. The essence of them writing their observation is just for me to confirm that they actually watched the video. So it won't look as if you ask somebody to narrate the story to you. You know, some of them can be funny sometimes. So because I wanted them to know that on TikTok, it's not just about dancing. It's not just about listening to music or looking for people that are doing skits. There are opportunities on TikTok where you can learn more, better than what you are being taught in the classroom. And this you encourage them that if they want to do TikTok video, they don't need to be dancing in front of the camera. They too can do something meaningful that will help them in future. When they look back or when the internet is bringing back reminder for them, they will look back and be happy that, yes, I did it sometimes ago, not somebody that is dancing naked in front of the camera. For mathematics, we have topics like calculation and measurement. How do we incorporate space science in mathematics? We can apply astronomical data like distances between planets using mathematics calculation and understanding scale. If you give them, okay, all planets revolve around the sun, what is the distance of the Earth from the sun? Or what is the distance of the Earth from Saturn or Jupiter or any other planet? We can calculate it, even if you are not getting the accurate measurement, but we can use it as a way of incorporating space science into mathematics, because all you need to do is the normal measurement, the normal calculation, group the students, you do this, do that, and you give them the skill of which they are going to use. This brings out the beauty of that topic, measurement. Under geometry and space exploration, we can explore geometry principles in planetary orbits, telescope, lenses, and spacecraft design, bringing mathematical concepts with real-world application. When you go online, watch video in relation to that topic. By the time you introduce it to them, these learners are fantastic. All they need is a little push for them to know that this is what we need to do. And before you know it, they are far beyond what you think they can do. In subjects like geography, geography is done in senior class, not in junior class. We can learn about the structure of the earth, the position, the movement of the earth, the shapes of the earth, and not in the theoretical aspects. You can ask them to hold the earth and or do something like a skit or animation, because they are in senior class. Some of them, you can incorporate that skill of animation in them to design the earth. How do they wish the earth looks like? After seeing the reality of the video, okay, this is how the earth actually looks like. So how do you wish the earth looks like if you are to design the earth? Then we can explore the weather and its effects. Just is another aspect of space science we need to know. Before an astronaut will go to space, before the space scientists will work, they need to understand the weather. And this is one of the functions of the satellite, weather satellite in space. So we, as a geography teacher, we can look from that aspect. Okay, how do we calculate the weather? How do we determine the weather? How does the weather affect the different planets? Then we can also look at the remote sensing of the satellite. There are different satellites in space. What are their functions? As a geography teacher, there are some things we would know that they are related to us. When we look at space video, you understand the geography aspect of space video that you can actually incorporate into your scheme. And when we are saying incorporating it into our scheme, we are not saying that we are changing the topic. No. You just have to look for, okay, which topic am I teaching this week? How is space science related to it? What can I bring in on space science to bring reality of the topic I am teaching? So that these students will understand it better and understand the application and what is expected of them now and in the nearest future. In agricultural science is for both junior and senior schools. We can look at how farming is being practiced here on Earth and how can it be practiced in space where there is little or no water. And for an agriculturist, you should know that the plant does not necessarily need soil for them to survive, for them to grow. So they can grow without soil. So what are we doing in that aspect? If we are to grow a plant without the soil, what resources do we need? How will the yield be like? Will it be better or will it be reduced compared to when it is planted on the ground? We can also talk about farming techniques in space, like the hydroponic, aeroponic, and different kind of things like that. So we can just read through and see how we can bring this thing, because everything we are doing rallies around the fact that by the time our students finish secondary school, we want them to think outside the box. We want them to understand that opportunity can come from anywhere. You have to be diversified in your thinking, in your doing. Knowledge is not static. Learning is not static. You have to be dynamic. And we can also explore how space agencies, how they work, how do they get their information? Okay, if we discover a plant and we want to work with any space agency, how do we get across to them for them to help us to find out if that plant can survive in space or not? Presently, space science is working on how to have a second home for humans, how we move into Mars, that how long can human beings survive in Mars? So these are some of the things we will need. Human being cannot survive without eating, so we need plants. Those plants that will be planted in Mars, how do we get them? We have to take them from this planet to that space. So how do we get them? We need people to help us out in that field, in that area. In English, as an English teacher, we can incorporate space science through fictional stories about space. Let them come up with a drawing, with a poem, a literature, a prose, something like that, and see how technology, how space science, everything can affect them. What does the future look like? We can make them go into debate. Is another way of incorporating space science, because if you are to debate on a topic, definitely you have to read on that topic. Whether you want to support, you want to against that topic, you need to read. So in the course of reading about their presentation, they will have to understand what space science is all about. How does it affect humanity? How does it affect our environment? How does it affect us as a whole? Then it also helps to develop their vocabularies, because most of the things related to space are scientific in nature. Some of them, except you use advanced Oxford Dictionary, you won't see them in some dictionaries. You can only see them in science dictionaries because they are scientific terms. But all the same, this ignites their curiosity and broaden their knowledge. Give them this growth mindset of, okay, what is this thing talking about? How do I navigate between my literature class and the use of AI, then the space science? Now, before I conclude, for some of us, we look at it as, how do I start? What if my topic is not actually related to space science? Or sometimes the inspectors will come to school and tell you that you are teaching what is not in the scheme. But for me, like I always tell them, if you are in the office, that means you are not on the field. I am the one on the field, dealing directly with the students. You can't know my student better than I do. You know what you can do to make your students happy in the class. You know what you can do as a teacher to gain the interest of your students, to gain their passion and their affection. So when you are teaching and you are doing some things that these students enjoy, you will not be the one seeking for their love or something like that. They want to see you. They want, because they know that every time you come to their class, you are coming with something new. So they want to relate with you. They want to learn something new. Even if you are not available, they will ask you, okay, if you are not going to be around, what should we be doing? What can we do? Or should we do this? They will suggest for you because they want to learn more. But somebody from the office can come and tell you that, how is space science related to English? How? Because they are not in the field. This area of a thing we are talking about, initially when it all started, like the reproductive sexuality education I talked about initially, it wasn't something funny. It wasn't something everybody was willing to accept at the beginning. But because the teachers involved, they understood what the team, the objective of the whole thing represent, they were able to convince people outside the classroom the essence of incorporating sexuality education in the school system. That students need to understand who they are, their values, so that nobody from outside will come and deceive them because they don't know, they are not aware. But something that they are aware of becomes part of them. They understand it better. The same thing is what we are doing now. This space science is something we need to let the students understand from their own points of view, not us, the teacher, putting everything in their. All we need to do is to guide them in seeing the light. How they will see the light depends on them, not on somebody that is not in the classroom, because they may not understand your objective. In conclusion, space science makes learning engaging because it is something very easy to incorporate regardless of your teaching field. And it makes learning more enjoyable. In fact, if you attempt to do one thing from what the previous speaker spoke about, one activity in space science, you will see that The next time you want to go to class, the students are already waiting for you. They want to see what is the next experiment. They cannot wait. And it also brings out the creativity in them. If you are able to do one experiment in their presence for them, believe you me, the next time they will give you different ones, especially those in senior school. Even when you are tired, they will tell you they can do something because they want to showcase their talent. For you to know that they are not dull at it. It's just that we have not been able to discover their strengths. All we are seeing is their weakness. And when we invest in STEM education through space science, it will empower more Nigerians to go into space education and space science. They will not have to wait until they become graduates before learning about aeronautic science, space science, and all that. Because most of the universities in Nigeria, they don't even have the courses. You have to do like a diploma, part of it in Nigeria, travel abroad to go and do the remaining. But by the time we start doing all these things, right from secondary school, we'll see that before we know it, it will transform into university curriculum. And once it is there, they put it into action and we all enjoy it together. It's not about us now. It's not about today, but it's about the future of our country. Thank you for listening. I really appreciate it.
Fantastic. Thank you very much for this enlightening exposition. My hands couldn't stop writing. I just kept writing. Now it's time for questions. If you have questions, I will read from the YouTube chat right now. Somebody says a very nice presentation, spot on the point, Augustine Kiki. Denu Joy says, can this be included in our curriculum, especially in the behavioral objective? This is because some supervisors do insist on you writing it the way it is written in the scheme of work. Should I take that again?
Yes, I actually had it. Like the example I cited, it is not a new thing. You can add it to your objective, and if the assessor or somebody from the OEQ comes around to ask you, your ability to defend what you are teaching makes you more powerful as a teacher.
Thank you.
We don't need to be rigid and be fixed to the scheme. The scheme was designed by somebody. You are the one on the field. You know what your students are capable of doing, and you know how best they can learn. So whatever you can do to make them learn is what we should do as educators.
Thank you, ma'am. How can a foods and nutrition teacher incorporate space science in teaching the subjects? Foods and nutrition teacher.
Yes, food and nutrition, more or less like home economics for the junior class. We can look at the different kind of food that we eat. We have numerous food that we eat in Nigeria. Is it possible for everything to be eaten in space? No. Can we grow all of them in space? No. So a food and nutrition teacher can say, okay, rice now. If we want to, we eat rice, we cook rice in a normal way. Is there any other way we can preserve rice to be eaten without cooking it the way we cook it here? Which is very possible. Because for the astronauts, they don't eat heavy food. They eat light food. But rice too is part of it. All they do is the rice will not be cooked as grain. It should have been blended into something like cereal, cooked and dry. So when they want to take it, they take it like cornflakes. But in the actual sense, it's the same rice we are eating here.
Fantastic. Do you know that pizza and pizza, shawarma, all these packaging of foods that we see now,
Yes,
they were products of providing stuff to meet the astronauts' needs, especially that pizza. I didn't know pizza was just bread. It was just the way they processed it. And we spend a lot of money buying pizza. So you can design meal plans in your food
all
and
you need
nutrition.
to do is about your creativity.
Exactly. Yes, do we have questions in here? If you need to go and pray, the recording will be here for you, and you can always come back to watch the recording before you take your evaluation, right? So I'll ask one more question from here. They said, do you think students who are preparing for WAEC can be involved in or excused from this program?
You can involve them.
What space?
The only thing you will avoid is encroaching into their time. But you can nurture that. They are still confused of what field do I want to go into.
All right, I think that's about all we can take for now. Thank you so much. I want to check the chats here if we have any from inside house here. No, none for now. Right. Thank you so much, ma'am, for taking time off your busy schedule to speak with us. This is my favorite part of the program, where we all get to take a group picture. If you still have further questions, please leave them in the chat. I believe that she has done a fantastic job enlightening us that it's not just about STEM subjects, it's about all subjects, as long as it will help you to provide solutions. It will help you to think creatively and critically. You need to think of, there's one eatery that what marks them out is that they can offer as much as 7 different types of rice meals, apart from jollof rice and fried rice. You see, they have village rice, they have palm oil rice. These are products of creativity, and people are paying so much. And when I tasted the food, I'm like, I can do this at home instead of spending much time, So get your students thinking to provide solutions. Business studies, it's very business, all the business we are doing here, Right. So are we ready? If you can, turn on your camera and give us a very beautiful smile. And I will count 3. Let me spotlight let me make it like this. Hold on a minute, please. Okay. All right. 3, 2, 1. Taken. Thank you so much, Ma. We appreciate you. And we would still have you some other time as well. Thank you so much. Now, everybody, can we show Alaja some love? In the comments, let's, pump the love. Let me send some love. Oh, love, 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 love. Let's use the reactions, the emojis to appreciate her. Give her some virtual dollars and pounds sterling. She has poured out so much for us. Thank you so much, ma. We appreciate you. So it's game time. Game time. So I would just let me see. Continue with my presentation earlier. I would share my screen shortly. Game time, game time. Who can tell us how many subjects she mentioned how we can incorporate STEM and space science into them during the course of our presentation? How many? Mention them. Let me see. I believe you are using the chat. I believe you are using the chat. If you missed any part, this program is recorded live so that you can always come back to it if there is anything you didn't get. So mention the number of subjects she dealt with in her presentation. Okay. I thought somebody would even ask, what's my business with engineering? We don't teach engineering here. I think it's just the terminology. It's about the various terminologies we use. We do engineering in biology, in physics, in chemistry, when you have to construct things and all. Even in computer studies, computer science, space science is everywhere, regardless of the subject you are teaching. Space, you can always incorporate and integrate space science education, because space science education is a very potent tool for us that teachers can use to raise a new generation of students who are problem solvers, who are critical thinkers, and who are solution providers. Are you with me? Are you with me? If you are with me, let me see in the comments, say, I'm with you. If you are with me, let me know you are with me and I'm not on my own. Let me know you are with me. So I believe we can still take more questions, or we can just stand and stretch. Let me know, what should I do? Should we continue with the games, or I should continue with my presentation? Should we continue with the games, or I should continue with my presentation? Let me get 10 responses. If I get 10 responses, I will know. Pick. Should I continue with the presentation, or should we play the game? This is a time when we rest a while before we continue. I want to see your response. Let me know what we should do. Should I continue with let's play the game? More games, more games, more games, more games. Okay. Let me see. The link to that game will be posted shortly. More games. Let me see what they said on the YouTube platform. More games, or do I continue with my presentation? Games are won. Oh. How many people said games? Okay, so for those of you who are in here, let's play a game. Where are they? I just want to confirm from the YouTube channel. One minute, so that it's not just one-sided. Oh. More games. What did they say? Six. Okay. So on the YouTube platform, I can see that we should continue. For the YouTube platform, we have that I should continue with my presentation. So we have more people saying continue with the presentation on the YouTube platform than here. So they have it. Okay, so going on with my presentation. So I was telling you that this is a guide. I was asking, how do you get started? So our objectives, we want to understand the importance of space science, the importance of space education. Let me confirm that you can see my screen. Can you see my screen, please? Can you see my screen? Can you see my screen? Yes. So we learn to set up and manage a space club, explore activities and resources to engage students, and network and collaborate with fellow educators. Do you see this particular part? Let me use the highlighter. You see this particular part, network and collaborate with fellow educators. This one is very important. because it underscores the importance of collaboration and interdisciplinary team bonding. In the presentations by our colleagues, you heard them say that this space exploration process is not something that any individual country can carry out single-handedly. And as we speak, Nigeria is not even one of the countries that have representation in terms of space exploration. There was a particular crest were given that showed all the countries that are representing in space exploration. Okay, I will take a picture now and send it to. There's a picture of that country, those countries, but Nigeria is not there. And you see, when we network and collaborate, we'll be able to do a lot more. As team means together, everyone achieves more. So it's important, you are not alone. So why space education matters? Why does space education matter? Space education inspires curiosity and problem-solving skills. Can you see that? It inspires curiosity and problem-solving skills. Look at the students. I just gave them a task. I asked them to build rockets. Can you see this boy's face? Can you see the concentration? Can you see the teamwork? Can you see that no one is left behind? Right? So they are solving a problem. I told them, this is what I want you to do. How do you make the rockets launch farther and fastest? Do you see a common denominator among all the facilitators? They will usually start by asking you questions. That is what you should also do when you get to class. Avoid that method where you go to class and start telling them everything. Those things you are telling them, they are already stale information. They are not even in the present age. These Gen Zs, let me borrow that their term. What they know, they know some things more than we do. Do you know that my daughter, my 12-year-old daughter, this is my smartphone. I couldn't, what's it called now? Increase the volume because the control panel that I used to increase or decrease volume removed. So I had to get a phone pouch to protect that place. And I've not been able to increase volume ever since. So this girl comes to me and shows me how to do it. Do you see that? And I didn't know. So another thing is we must be humble to learn and to come down to their level. Space education also helps them develop teamwork and leadership. So somebody will just automatically assume the role of the guide. Look at this boy. Can you see? It's, you know, that's how you identify potentials. Do you understand? So And these soft skills, they are things that we cannot read in black and white. Soft skills like compassion, communication, showing empathy. You know, when everybody together, everyone achieves more. All for one and one for all. Together, everyone achieves more. No unhealthy competition or rivalry. Space education also encourages future career paths in science and technology. Now you know that technology is an integral part of our lives. Whether you are a STEM teacher or non-STEM, every one of us use technology. I am leveraging technology to reach out to over 1,500 teachers. If I was to do that using physical means, traditional means, I would not be able to do much. I would have to contend with where do we get the venue and all that, food, water, transportation, and all that. If it was funded and I've received funding, you know, you would have to put all those things in place. But you and I are here. I want to drink water now. I just take my bottle of water and I drink water. If I am hungry, I will get food and I will eat, and the training is still going on. So technology has become an integral part of our lives, that whether you are a STEM teacher or a non-STEM teacher, you are using technology. So you want to encourage them to pursue jobs that are beyond white-collar jobs now. The future is already here as we speak. Can you still hear me? Let me know if you can hear me. The future is already here as we speak. There are some jobs that are now available that they are not white-collar jobs, and we need to prepare our students to fill those roles. We don't want them lagging behind in any way. There's no excuse for any of our students to be lagging behind. Can you hear me, please? Let me put it in the comment, in the chat. Can you hear me? Can you hear me? Can you see my slides? Okay. Rajitoyin, you already know what I was going to ask. Is there a screen scene? I need to be sure, because the way network could be dealing with us there. And I can see your screen. Say I can hear you and I can see your screen. Please chat that for noble colleagues on the YouTube live chats. So it encourages future career paths in science and technology. These are the astronauts these are the crew members of the Artemis 2 flights. They are going on a mission to the moon. And you can see this woman there. She's the only woman there. So beyond being an astronaut, they can be anything they want to be. They can be anything they want to be. So there is no limitation for them. Okay, I can also see your screen. All right. So getting started, how do you start? Set goals, determine the club's purpose. What is the purpose of your club? There are a number of purposes that your club can be focused on, or you can have a combination of goals, but you need to define your club's purpose. One of the facilitators yesterday talked about the different purposes that you can establish the club on. So can somebody chart some of the various purposes that you can set up your space club for? What are those purposes? Adeola Akinshulure, she mentioned define the purpose and objectives, and I noted all that. So are you charting it? Let me know. Define your club's purpose. What's the purpose you want your club to be set up for? You know, they say that you need to know your purpose in life. You need to know, before you start anything, there must be a purpose. Why am I holding this training? Why don't I just, enjoy my meeting break and just find somewhere to rest and relax? What's the purpose? You can either have it to provide hands-on experiences or to keep the students informed or to go for competitions. So you need to set clear objectives and identify your learning outcomes. You don't just, yes. Thank you, Olayiwola Dorcas, to promote interest in space. That's where we get started. Moving on. So your club also has to have structure and management. And of course, you need to write to the appropriate authorities and get their approval. If you need a template on how to write to seek approval from the authority in your school, because we can just start at the cellular point and then we can now, it doesn't take so much, right? Just like we have the Jets Club, we can also have space clubs. So somebody says to promote creativity. Yes, very important. To promote creativity. It is very, very important to promote creativity. Somebody says to connect students to opportunity in space. Very true. We need to be actively doing these things, connect them to opportunities, right? Let them connect to opportunities. There are some information that I get access to, I share it in the club. Another person says the club's purpose is to increase the students' knowledge in sustainable development goal and to increase the knowledge about space science. That's good. So what should be the structure and management? What's your role as an educator? Your role is not to come and give them all the answers. Your role is just to be a guide, right? They will choose their leaders themselves. So you make student leadership opportunities available for them. Determine the meeting frequency and how you want to raise funds, because you will need funds. So meeting frequency, how many times during the week, because you don't want to get into trouble with calling to ask why their children are not back. So there needs to be a very good way of managing that part. So once you have gotten approval from your principal and the authorities, the head of departments, the authorities, we all know the authorities. Once you have written to them and you have outlined in that your proposal, the time and frequency of meeting. And I'm sure the authorities are very understanding people. So in case anything happens, they can vouch for you. I do that. When I wanted to organize private lessons, I mean, not private lessons, after school free lessons, I had to write and ask for permission from the authorities. And in my letter, I stated the frequency of the meeting. And so when we are done with after school lesson, for instance, at 3 p.m., we had that thrice a week or about twice or 3 times a week, as depending on how my schedule permits me. So when the parents call that my child got home 4 p.m., the authority already know that I am not holding them back, because I've already stated the time our meeting ends. So the time, and then for fundraising, most times we do bootstrapping. I usually, if we have a project we are working on, we come to the table and say, these are all the items we need. And everyone contributes in their own little way. And I, as a coordinator and the guide, right? I'm the guide, I'm not the leader. I'm just providing guidance. So depending on the project we are working on, we lay the cards bare. Those who have this or that, because we are still starting small, we have to bootstrap. Then later on, we approach, we can write letters to raise funds. We can even get other ideas on how to raise funds, but those funds are basically when we need to do projects. I remember there was a time we wanted to make plastic waste. So we needed glue, we needed paint, we needed different things. Everyone brought the items we needed, including myself. So it may not even be just money all the time. So students need to be engaged with hands-on activities, building model rockets, solar gazing, organizing telescope events, participating in space-related contests like space art contest. Some of my students participated in the space art contest, and they designed this mission patch themselves. This one was for the microgravity experiments, because when astronauts go to space, they always have a mission patch. For history teachers, there's something about storytelling, history of all the missions that the astronauts have gone on. And, these things have a way of, the role of history. We must not forget where we are coming from, right? So it has its part in storytelling and chronicling events over the time. Then what else? Collaboration and partnership. So I basically use a lot of NASA and ESA resources. While this is for the United States, this is for Europe. This ESA it's a website. Just go on to type ESA or NASA. So we have various resources there that we can use with them. So we basically use digital resources. We also have free software and simulators like PhET simulation. We have virtual reality headsets but we use what we have. Like I use PhET simulations a lot. We also have partnerships with universities. You can partner with universities. You can partner with parents, experts, and local communities. All these resources are available to you. This training is brought to you in partnership with fellow Limitless Global Educators, right? So you can leverage on your network. Even your students, some of them, they have well-meaning parents, you know, so can write letters to them, can ask them to come and do one or two things. Ask them. So sustaining the club's momentum. How do you sustain the club's momentum? Here is how to sustain the club's momentum. Celebrate students' achievements. What did I say? Can somebody sorry about that. Celebrate students' achievements. This is one of my students in my former school. She's very active. This is my environmental Bees Club handlers vest. So this is the mission patch for that we use to celebrate the outstanding work they do. You know, the mission patch I showed you back then. So I decorated that with that badge and we took a picture. And, you know, everybody was just looking at us. You know, there are a number of them like that in the club. So make sure their presentations, exhibitions, and awards, it doesn't have to be anything big. Small things done thoughtfully have a way of, yes, conduct awareness campaign during school assembly and going from class and involve them. Let them be the ones doing it. Just tell them what, give them tasks. Yeah. Give them tasks and don't be the one telling them how to go about it. Just tell them what to do. Give them tasks. Even ask for their suggestions. Organize annual events. In my school, my current school, we are going to have the Jets Day and we are going to have some rocket launch activities, you know, Astronomy Day. Somebody is coming to talk to us about astronomy shortly, introduction to astronomy. So you'll be able to incorporate that too. So we want to equip you with all that you need to be able to run and run successfully. Are you with me? So organize annual events, plan towards it. Plan towards it and make sure that you go. Right? Are we together? Are we together? Are we together? Yes. Keep students motivated. Keep them motivated. Invite guest speakers, just like I'm doing, assuming that we are the students. Our facilitators are our speakers, right? It doesn't even have to be outside Nigeria. Even myself, I can be a guest speaker for you. You can reach out to, you see, Jenny gave you her contacts. You can reach out to her. I've copied her email. I will put it on the platform and you can access it, right? So keep them motivated. Documentaries, go on trips. You can do it. Tell your neighbor you are limitless. Tell your neighbor you are limitless. No excuses. Say, I am limitless. I am limitless. No excuses. I am limitless. Say, I am limitless. No excuses. I am limitless. No excuses. Thank you for your attention. Do we have any questions? I will be in the comment box checking. I am limitless. Yes. This is our own mission patch that we designed. The 10 of us that were selected in Nigeria. We designed it and created it. See business studies. So when you business studies teachers, this is business. You can create these things and sell, and they learn. They are getting creative. They are getting creative. You understand? So there's no excuses. We are all very busy. I don't think there's any teacher here who is not busy. I don't think so. We are all super duper busy. That but we find time for what matters to us. So we have our next speaker coming up now, Professor Dr. Lucas what's that? Picanso. Let me show you. Professor. Professor, you are welcome, sir. I'm asking you to unmute. Yeah.
Okay. Can you hear me now?
Yes, I can. So before you start, I just want to quickly go over your profile with our noble colleagues, right?
No
I
problem.
want
Go
to
ahead.
read the profile so that they know who is with them this afternoon. Please confirm that you can see my screen, distinguished teachers. Please confirm that you can see my screen. Can you see my screen? Can you see my screen? If you can, let me see it in the comments. Please let me know that you can see my screen. Am I on my own? Can you see my screen? Let me check with folks on the YouTube. Can you see my screen? Yes, I can go on. Let me see. Okay. So I've confirmed that I can see my screen. So Professor Dr. Lucas Teixeira Picanso holds a degree in physics. He also has a master's degree in physics teaching and a doctorate in science and mathematics teaching. So mathematics teachers, get in here. He conducts research in the field of inclusion of deaf students, and has recently dedicated himself to teaching astronomy with a focus on space exploration. He is also an ambassador for the Limitless Space Institute's Limitless Educators Program. Make welcome Professor Dr. Lucas Picanso. Can we give him those likes? Clap,
Okay.
clap, clap. Welcome.
Uh, Thank you so much for the invitation. I'm
Yeah.
very glad to be here today and little nervous. As you know, English is not my first language, so I apologize. Uh, anyway,
Just speak slowly
okay.
and calmly. We will hear you. Don't
Okay.
speak in a rush. Just speak slowly.
Okay, cool. Thank you.
You're
I'll be
welcome.
calm. You know me. Okay, I will share my screen with you. Let me know if you see, okay?
Yes.
Okay, everyone see?
Yes, we can see your screen.
Cool. Okay, here we go. In this presentation, we will address the importance of teaching astronomy in a public school, and specifically in my hometown, Parintins, Amazonas, Brazil. We will explore everything from the introduction to astronomy to the implementation of practical projects that engage students, promote interest in science. We will start with an introduction to astronomy, discussing its definition, importance, and main areas of study. Next, we will analyze the educational context in Parintins, addressing challenges, opportunities. Then we will focus on the implementation of astronomy education, include the design of curricula and teaching methodologies. Finally, we will explore hands-on projects and the expected impact on students' engagement.
One moment, please, Lucas. Can you speak a bit louder?
Okay.
Yes. Closer to the...
Better
yes.
now?
Better.
Cool. As you know, astronomy is the science that studies celestial bodies and the universe as a whole. Since ancient times, the observation of the stars has fascinated humanity, and it's linked toward understanding of the world. Let's look at how astronomy influences everyday life and its importance as a field of study. Astronomy is the science that investigates celestial bodies such as stars, planets, comets, and galaxies, as well as a phenomena that occur outside of the Earth's atmosphere. This area of knowledge uses observational methods and physical theories to understand the origin, evolution, and behavior of the universe. Astronomy plays a crucial role in understanding of the universe and our place in it. It helps us answer fundamental questions about life, time, the formation of planets, and the evolution of stars. In addition, astronomy also promotes the development of technologies that impact daily life of society. So it's very important science. The main areas of the study of astronomy include astrophysics, which analyzes the physics of celestial bodies, cosmology, which investigates the origin of and evolution of the universe, and planetary astronomy. It studies planets and satellites. Each of these areas contributes to a more complete understanding of the cosmos. Here, a little bit from the river, Amazon River. So the educational context of my hometown presents both challenges and opportunities for teaching science, include astronomy. We will analyze the situation of public schools, educational initiatives, and how we can improve teaching in STEM. But first, I would like to show on the map where is my hometown, Parintins, is located in the middle of the Amazon rainforest. By the way, it's raining cats and dog right now.
Really?
Here.
It's not
Yes.
raining here at all.
Uh, so between us, there is more than 7,000 kilometers to Manaus, distance from Manaus to Abuja. Yes, Abuja, it's okay?
That's a lot.
That's a lot. So this is my state in Brazil. Brazil is a huge country, as you know. And the Amazon state is the most of big one state in Brazil. I believe it's the great state, the major. So this is Amazonas, and right here is Parintins, my hometown. And this is my beloved Parintins, the princess of the Amazon state, as you know. Okay, but we have great issues to trespassing. For example, last year, we have a big problem with because the river drew up a lot, isolate communities, and even interrupting some schools. So the problem of the climate is really huge here too. So public schools in Parintins face several challenges, such as lack of resources, bad infrastructure, and shortage of teaching materials. However, there are also schools with innovative projects that seek to incorporate science teaching in a more practical and interactive way, like my school. Challenges include resistance to teaching new subjects and a lack of teacher training in science. However, there are opportunities through partnerships with higher educational institutions and training projects that can improve educator trainers and students' learning. Here, I would like to highlight our partner, the Litmus Space Institute. Without you, many of these activities would not be possible. I have shown. Recently, some educational initiatives have emerged in Parintins, promote an increased and interest in science fair projects, workshops, and lectures with experts help to stimulate students' curiosity and the appreciation of scientific knowledge. This is the logo of my project, the Iron Man, the Messenger of the Stars. It was developed last year in my school.
Can you please put the microphone closer?
Okay, better now?
Better now.
Cool. The implementation of astronomy teaching in schools requires the development of structured curricula. We will discussing the methodologies to be adopted and the resources needed to ensure that the teaching of astronomy is effective and engaged. So, I would like to show you this video. In this video, we see the students present the vision of the indigenous people of the Amazon on astronomy. Some made representation of constellations with electro circuits, art, and dedicate themselves to present the astronomical knowledge of different cultures. So let's go. I love to see this video. The astronomy curriculum must be adapted to the reality of the students with a practical and experimental focus. It is essential to integrate theoretical concepts with activities that allow observation and experimentation, making learning more dynamic and interesting. So you can see the kids play with the sphero boat. It's a cool active. Adopting active methodologies such as project-based learning and collaborative learning is essential for astronomy education. This approach encourages students' participation and promotes deeper, more meaningful learning. Here we see the students represent their constellation with electro circuits. Of course, for astronomy education, research such as telescope astronomical simulation software, and teaching materials that explain basic concepts are needed. Using technologies such as stargazing apps can improve the student experience. Hands-on activities are key to astronomy teaching, as they allow students to experience science directly. We will discuss different projects and activities that can be implemented in schools to engage students and solidify learning. The first, we have the astronomical observation. Of course, astronomical observation is an essential activity that can be carried out in schools. The use of telescopes allows students to observe planets, stars, and other celestial bodies, sparking interest in astronomy and science in general. But don't worry if you don't have a telescope like this, no problem, because we need just a simple plastic like this, you can see, okay? Just point the stars and make their mark like this. It's a cool, active, and cheaper, very cheaper active. So anyone can do that, all right? Another way to improve the teaching of astronomy and any science, I think, is science fairs. Science fairs are an excellent opportunity for students to present projects related to astronomy. These exhibits not only promote scientific knowledge, but also encourage teamwork and the development of presentation skills. So it's very important too. Visits to planetariums and research centers provides great experience too for students. These venues offer hands-on demonstrations and lectures that can be inspire students to study astronomy and science in general. Here you see the Iron project. I try to do a planetarium, actually. Astronomy teaching in my hometown has had a significant impact on students' engagement. We hope that this approach will spark interest in science and promote the development of critical and analytical skills, preparing students for a promising academic and professional future. Students are more engaged and curious and stimulated to seek more knowledge. Here we see two students carrying out an active development by one of the educators of the Limitless Space Institute, the Professor Francisco de Assis. It's a great active. Here we see the students play with the spherical bolt and solar system representation. It's a cool and very good activity. The study of astronomy develops critical and analytical skills in students, as they are challenged to solve problems, formulate hypotheses, and interpret data. These skills are essential not only in the sciences, but in several areas of knowledge. Here we see three more activities done with the support of Limitless Space Institute. The first one is a challenge of the solo car and parachute launch. It's a great activity. The kids love it. Do that. And the solar sail right here. So, with a strong foundation in science, students can consider career in the fields of astronomy, astrophysics, engineering, and many others. Okay? Astronomy education can open doors and provide valuable opportunities for a bright academic and professional future. I'm very, very thankful for the astronomy in my life because I make my first international trip last year because of that. I'm very glad to be a physics teacher and astronomy teacher. So, in conclusion, teaching astronomy in my hometown is a valuable opportunity to inspire students and promote interest in science. By implementing appropriate curricula, dynamic methodologies, and practical projects, we can prepare students for a future full of possibilities in the scientific fields, because we are limitless. So thank you, guys. I'm here for any question.
Can we give Professor a round of applause? Please give Professor a round of applause. Thumbs up, the bomb. I can see the bomb in there. People are, wow. That was a fantastic presentation. I can see in the comments here, say very clear, very clear. So the message was well driven home. So now let's go to questions. Adeyemi Oluwatoyin has a question. Please unmute and ask your question, madam. You are raising your hand. Can you unmute? I'm asking you to unmute, Adeyemi, so you can ask your question. So we have a few questions before we let you go. One question says, astronomy. What are the simple materials that we can use to start astronomy lessons with our students in our space clubs?
Okay, great question. I would like to show you again. Can you see? Can't you see or not? Okay, it's a plastic. How can I use that? Just point the stars and make the mark. It's a very cool activity because you will teach your students how can they do a map, a star map, okay? Map of the stars. So we just keep in mind that we didn't have telescope before Galileo Galilei. So how the other cultures could see the stars and make maps before that. So you can do this too. Just look the stars and make your map, and another day in the classroom, you can discuss about argue about the knowledge that your students could see in the sky. Just a very, very simple activity. Okay?
Noted. Another person asks, is astronomy related to geophysics? Is astronomy related to geophysics?
Okay. Of course, when I teach astronomy, I always take many shows about physics, like Newton's law, Kepler's law, and this is a great moment to inspire the kids to apply that knowledge in this science. So astronomy also have big content in biology, chemistry, not just physics. It's a great area to relate relationships with the other knowledges areas. Okay, so you can improve it. Math, physics, chemistry, and biology in this area of knowledge, astronomy. Okay.
Awesome. Awesome. Thank you so very much for that fantastic and clear presentation.
Cool.
That was
Thank
a
you
very
for the
clear
invitation.
presentation. We appreciate you. So it's time when we take the beautiful pictures that we usually take. And if you will, can we turn on our cameras for those of us who can? And we pose for the camera. 3, 2, 1, taken.
Thank
Wow.
you, guys. You rock.
Thank you. We
Keep going the
appreciate.
good work.
We give you clap, 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 clap. Let me clap for you. Let me give.
Thank you, Banky.
I'm clapping for you. I'm clapping. I'm clapping. And I'm
So,
giving you some balloons, plenty hearts.
bye, guys.
All right. Take care. Thank you. Right. Up next, we have the state champion of Enugu State for the Multina Teacher of the Year Award 2024. 2024. We have giants in the education sector, people that when I look at the work and the impact they are making, I am just like, you never start though. There's work to do. There is impact to be made in the lives of these beautiful children that God has committed into our hands. So we are going to go on now to have Mr. Abraham Ngobiri. I want to quickly share my screen now to tell us a bit about Mr. Abraham Ngobiri, who is here with us live. Confirm that you can see my screen, please. Can you see my screen? Can you see my screen? Can you see my screen? Let me know if you can see my screen. Okay. The next speaker, his name is Mr. Abraham Ngobiri, the 2024 Multina Teacher of the Year Enugu State Champion for the top 10 finalists. He also won he's also one of the 10 Limitless Global Educators, Limitless Space Global Educators. He's from Oru in Imo State, Oru West in Imo State, and he resides in Enugu State, Nigeria. So we are bringing Mr. Abraham all the way from Enugu State. We flew him through Mars, through Wales, through the galaxies. We flew him across the moon, and then we landed here on Earth just for you. He is a passionate teacher with the Federal Government College, Enugu, and Prime College, Enugu, where he teaches biology and basic science to grades 7, 10, 11, and 12. Ngobiri Abraham is the lead volunteer with the Teenagers Transformation Initiative, an organization saddled with the responsibility of raising balanced teenagers that will transform the society. Ladies and gentlemen, with a resounding ovation, applaudissez. Let's give him a round of applause. Use your reactions and emojis to welcome Mr. Ngobiri. Where is Mr. Ngobiri? Can you keep the chat box pumping? Let's give him a resounding welcome applause. Our folks on the YouTube, welcome Mr. Ngobiri. Mr. Ngobiri, you can unmute. Are you in here? I saw you coming. Make welcome. Biology teachers, get in here. We are a biology teacher. We are a basic science teacher. Your guy is here. Your guy is here. I hope the network has not bounced Mr. Ngobiri out. Mr. Ngobiri, can you unmute? I hope the network has not bounced him out. Because he was with us when Professor Lucas was speaking, and he has been in here. I hope the network has not sent him out. Welcome, Mr. Ngobiri. Welcome. We appreciate you. Welcome. Mr. Ngobiri. Guessing the network has bounced him out. Okay, Mr. Abraham is back in the building. Network has returned him. So distinguished noble colleagues, please, you know that you have a huge task committed to your hands now. To go and raise those students who will help us solve the issue of network so that we can have seamless communication, right? So, Mr. Abraham, you can speak. I've read your profile. We understand that the network
Good afternoon.
Good afternoon. Welcome.
Is my screen on? Is my screen on the is it showing?
Yes, it's showing.
Okay. Good afternoon, everybody. Good afternoon, wonderful educators. Good afternoon, limitless Mrs. Olumbanke. It's great and an honor to be on this workshop. And we know we're here to gain information, and we believe that our students will be very opportune to have us as teachers, as educators, who is making great efforts to see that they become much more better than we are. And we want to say thank you to Doc for making this opportunity available. Thank you for the privilege, Ma, to be on this workshop. Thank you. So straight to the point, I've been asked to talk about integrating space education into biology teaching. I know most teachers are great biologists in the house, and the number one question that came to my mind when I got to know about space was, is there a relationship between space and biology? You know, because people will want to ask, this is space now, like, what does it have to do with science? What does it have to do with our subject? But the truth of the matter is, space education can be integrated into various facets of our discipline. Dr. Banke is a chemistry teacher, and I think basic science and all that. And we have so many of us are into different disciplines, and there are various ways we can, you know, various subjects, various topics that we can integrate space education in, because we know that our curriculum in Nigeria does not actually have a space, like we say, this space education curriculum or space education as a subject. So the best thing we could do for our students is to integrate it into what we teach in class, to give them that idea that, all right, in as much as we're talking about space, like in quotes, space, life also does exist in space, and that also includes biology. So I'll quickly go over to the introduction. We said this presentation will explore the integration of space education into biology teaching, highlighting the practical strategies that can enrich students' understanding. Okay, somebody said the voice is low. I believe they can hear me now, right? Can they hear me?
Can you hear him now? I can hear you fine.
Okay, all right.
Let me check if they
Okay.
can hear you on
Okay,
the
somebody
chat.
responded yes.
Okay.
Okay, so thank you for the feedback. All right, so we say space education not only captures students' imagination, but also provide real-world application for biological concepts, fostering deeper learning. All right, so space education also have an aspect where biology have to come in place. Like what we want to ask, maybe most of us might have imagined, like most of our students would have asked us, what happens in space? How do they feed? Do they farm in space? We've been taught that in space there's no gravity. What happens when these astronauts are upside down? All right, so these are questions that may want to prop up in the minds of our students, and biology has a way of bringing answers to those questions, right? So as I said earlier on, there are various topics in biology, that we can integrate space into it, not necessarily all the topics, but there are key topics like excretion, like respiration, like digestion, blood circulation. All of these things have to do with astronauts, because the fact that they are in space does not mean their life has been suspended. So every normal biological activities still happens in space. But what we cannot begin to bring into perspective is that, does life on Earth, is it same with life in space? Since we've been told that in space that gravity does not exist. So what happens to astronauts in space? So these are the things we want to see, and now we can bring that into proper perception. All right. So I have here intersection of space and biology. Okay. We have, or generally, we already defined biology as we know that biology has to do with the study of life, living things, what really happens on Earth. Okay. And we have human biology in space, and we're supposed to understand how space travel impacts the human body. Space ecology, examining ecosystem in space environment, including closed loop systems. Like for instance, somebody may want to ask, for example, like one of our trainings we had with those space educators or an astronaut, and he told us a story that there was a man, an astronaut, that the moment he came down from space, he returned back to Earth, that his bone broke. It's like somebody touched him and his bone scattered. That sounds crazy, right? Like, how do these guys really survive over there? Because we were also told that if these guys return back to Earth, they keep them in a secluded place for some time in order for their body to recuperate back to the normal system on Earth. So these are all stuff that we will want to see this afternoon. Okay, so we have all of this. Now we have what we call the ISS, that's International Space Station, where research most times are being done and all of that. So we want to quickly run over because of time. Now, I did mention that there are various aspects we can actually incorporate in our classes. For instance, we have understanding human physiology. We say space travel poses unique challenges to the human body, including muscles atrophy, bone density loss, and exposure to increased radiation. All right, so what are the activities we can incorporate in our classes? We say students can stimulate this condition in a classroom by studying the effect of prolonged inactivities on muscle strength, or exploring the role of calcium in bones health. As I did say, astronauts, when they travel to space, there is a suspension of their body activities. That includes their bones, that includes the muscles, that includes exposure to radiation. Okay, and most times we could bring an illustration to our students, like when you could ask a student to sit down and suspend his or her leg maybe on a table for a while. Okay, because in space, these astronauts don't actually have gravity, so they are suspended. Okay, if you go over to the internet, you could see videos on how they sleep. They just put their body somehow, right? Because there is no gravity. And all of these things have ability to impact on their bone density. Because since their muscles, there will be no work for their muscles to do because they are just floating. This aspect could be taught during supporting systems, supporting tissues.
We can't hear you.
Oh, really?
Hello, sir.
Okay.
We can't hear you. You are muted. The last thing we heard was bone density. No, it's still not speaking. You are speaking, but we can't hear anything.
Okay, I think they're showing me the host is not allowing participants to unmute themselves. So
now I can hear you.
Okay. Can I be heard now?
Yes.
All right. So thank you. Somebody said they are weightlessness, right? So weightlessness affects bone density in space because just imagine we as human beings floating without landing. All right. Now we can, as I said earlier on, we can incorporate these aspects when teaching skeletal system, right? And we can bring it furthermore when treating things like bones. We treat things like muscles, right? We treat things like bones and movement. So we can incorporate human physiology as regards to what happens to the astronaut physiology in space. So this will give our students a clue to what the body physiology of astronauts or what really happens in space. All right, now space farming. Somebody may want to ask, do people farm in space? Yes. Now, this could also come in aspects of germination. Like we've been told severally, or those are our biology teachers, we know that we have conditions for germination, like the seed must be variable, it must be water, there must be moisture, there must be warm air, and all of those, But do we have all these conditions in space, right? Now, yeah, thank you. Somebody said even teaching digestive system. Yeah. Okay, so we could have this element come into play when teaching germination. Now, we've been told in space that things can now grow. Things cannot germinate because they have been able to stimulate. There are many things that have been able, like your lead light you can see, soil, water culture environment has been created to ensure that germination happens. So basically what we do in biology when bringing space into it is to find a way to compare plants in space and plants on Earth. Okay, and students can also be allowed to discuss the challenges. What are the challenges you might experience to grow food in space? Okay, and as I've said before, all of these things are happening right before our eyes. Now, we have space technology in biology. Okay, now we've been shown a picture of the nature of the Earth from space. And I think there was another picture that was shown to us. I don't think it's in this, my slide, that was shown to us on the polluted nature of the Earth. So we can see when teaching pollution in biology, like most times we say the Earth is polluted, beautiful. But by the time we let students know that even in space, pollution do happen, like radiation. Radiation is actually pollution because when the human body is exposed to radiation for too long, it poses a problem to the human health. All right. So currently, satellite imageries and other space technology have been used to monitor Earth's ecosystem. Okay, understanding the global impact of environmental changes. Like in that picture I'm talking about, you see how polluted the Earth is from space. All right. Now, by the time you bring this to the knowledge of our children, our learners, now they will get to know that, of a truth, that deforestation is happening on everyday basis. Urbanization is on the increase. Climate change is a global phenomenon today, right? And all of these things, biology has a greater part to play in it. So space technology in biology is also very important because we have results from the ISS, that is International Space Station, about all of these things. And all of these are all available in the internet. So you can chip it in as you treat pollution and as you treat impact of pollution. Maybe you are teaching basic 9, 8, or 7, impact of pollution, or what we call environmental hazard, right? You can treat all of this when doing pollution, right? They will have ethical consideration. Okay, we should engage our students in discussion about ethical implication of space exploration, such as potential for contaminating other planets or the moral consideration of terraforming. Now, I know space is beautiful. It's a beautiful thing in our generation, and we're excited about it. Now, but the truth of the matter is, likewise, when dealing with pollution, we can also bring this to bear that pollution happens when a rocket is being launched, right? And that's why you notice that when a space rocket is being launched, it is launched far away from people. The last one that was launched by Elon Musk, most people watched it far away. Some were watching it from a room because there's always a communication from the space rocket and to the control room. But if you notice the hydrogen, the oxygen, the combustion that happens, all of these things are part of pollution. They also contribute to pollution, and it affects the general ecosystem of the Earth. All right. So all of these things, we could go deeper. You could also go deeper by helping your students to realize that the combustion stages of this pollution that has to do with space exploration also causes what? Pollution. And I said activities can organize a classroom. You can assign a topic or an essay for space colonization and its impact on human life and extraterrestrial environments. Now, by the time you help your students to do this, they will get to appreciate, what you're actually telling them. Because most times, yeah, it's true that space is beautiful, but we need to also dig deeper to the aspect of pollution and how it affects climate changes. All right. So we have hands-on experiment. This has to do with how we can discuss space in class and using by stimulating our environment in class, where we could have microgravity, or we'll have little gravity or no gravity at all, which is practically not possible on Earth. All right, we can just stimulate something in our class and see how these can explain deeper for our students. Like somebody talked about digestive system. Yeah, that's a beautiful contribution. We let them even in respiration. All right, even in respiration, we've been told that, right, the greater the pressure and the lesser the pressure and all of that, we could compare what happens, how do they breathe when they get into space. All right, is there oxygen? How does it affect the respiratory system? How does it affect the digestive system? All right, how does it affect their mental health? Does the brain still function the same way it functions? Does blood flows in the opposite direction? The normal circulation of blood, does it still work like that when they are in space? All of these things is to enable them to increase their curiosity about space education. So we can integrate space in biology in practical terms. We could do researches and let them know that, yes, human beings in space, if it affects their digestive system, you let them know how, and then you compare it to those of us. Do they excrete? Most people don't know that they excrete in space. They do, because that digestive system is still working. All right. I think the last time we went to US, they showed us a toilet seat in space and we sat on it. All right. So all of these things are beautiful things that happen in space, and we can let our students know as we teach our normal everyday subjects and classes and topics in class. So we have partnership in education. We have NASA NASA is doing a great work as it has to do with space education globally. It's just that, unfortunately for us in Nigeria, we are just getting to know we are getting to apply this, even in our classroom, because currently there's no curriculum that encourages us to have all of this. So we have engaged a program like Tomatoes Fair, where students grow tomato seeds that have been to space and compare their growth to earth-bound seeds. All right. So these are all things, but unfortunately for us, we may not have access to this type of, materials, but we can always get results, from the internet. We just pray that someday we'll be able to have access to all of this, where we can compare things in space and things on Earth. But for now, the best thing we can lay our hands on is to get results or research results from the internet. Thank you very much, and God bless you.
All right, that was a fantastic, fully packed with so many ideas presentation. Thank you, our state champion, for that excellent delivery. Any questions? Applaudis, say yes. You got ideas now. Somebody asked, what can we do? We are novice in this. You cannot be telling me that you are novice again. No? So many ideas. If you were listening thoroughly, you would have gotten a lot of ideas. But then it's time to ask questions. Let's applaud and give our Father Abraham many sons. That's how I call him. Many sons as father. So questions. I'm going to the chat now to ask. I'm going to the chats. Let me see. Are there questions? It's time for that part of the presentation where you ask questions. I always like when we ask questions. It's so heartwarming to know that you are following and you want to make this work. It's not about having one special curriculum, but it's about integrating what we are talking about into what you are already doing, because the journey is still a bit far, but we can't wait then.
Yeah.
We can do something now with what we have. Although limited resources, but we are limitless. So somebody says electrical energy. That's a topic. Somebody is asking, how do I integrate science when teaching electrical energy?
Which one's okay. Okay. Okay, can you hear me?
Yes, I can hear you.
I think I'm going to take the one from this one on teaching electrical energy. I think that should be physics. I don't know if we teach electrical energy in biology, but give us practical on how to teach nutrient cycle and space, and how do I integrate food and nutrition into space. Beautiful. Let me start from the last to the second. All right. Now, how do I integrate food and nutrition in space? That's a beautiful one. All right. Now, I think one of the ways to expatiate. Now, the fact we say that, the fact we say that in space education, that astronauts live a very normal life, and that is correct. Now, astronauts don't eat every type of food, because when on space rockets, weight is needed, weight is considered. Like, I know there are some experiments 10 of us from Nigeria that was selected wanted to do, and one of the conditions that they gave was that the weight mustn't be too much, because when traveling on the space rocket, they consider weight. I think part of the food they eat is they have a special meal that is not heavy, like, the way we eat now, right? You can take a wedu, take amala, they have a specialized meal. And most times when they need these meals, they are synthesized, right? And they send them up there with the space shuttle. And this food contains the necessary nutrients that they need in space. Okay, so they may not have to eat rice and all of those stuff that we take on Earth. So they have a specialized meal that also bears all the necessary nutrients that they require for survival. All right. So when teaching food and not, want to integrate it in space, just like you could state like the newborn baby, that is just being given birth, because of the nature that newborn baby is currently at that state. There's maybe you give them milk. Those milks you give them contains all the essential elements that little baby needs for survival. The same way is applicable to space. All right. They have meals that they take, and those meals also contains all the necessary food nutrients that they need for survival. Now, talking about nutrient cycle and nitrogen cycle, water cycle, and all of that. Now, when you see things like water cycle, right? Now, or nitrogen cycle, or carbon cycle, or oxygen cycle, as it were, we already know that in space, because of the lack of gravity, water cannot be recirculated, right? Because there's a video in the internet where they showed where water was poured. Instead of water to fall, the water froze, right? All right. And if you use an handkerchief to try to soak the water can't even pour down because of lack of gravity, right? So you could use all of this in illustration. Why in water cycle, we teach condensation, we teach transpiration, we teach evaporation, and all of that. But in space, it doesn't really happen like that. Water can't be recycled. Likewise, our nitrogen, except we are going to create a stimulated environment to make all of this happen. Like there's no bacteria, the Nitrobacter and the Axobacter, that convert thunderstorms and all those things you get. So these are the only differences that tends to happen. All right. So that is that as per, in space. Somebody say, is it possible for me to be using space science when I'm teaching Yoruba language? Of course, yes, you can use your language to explain space education. Yeah, you can. You can use your language to explain space education. Everything, like Dr. Ban Ken here, we met somebody that was teaching music. And in my head, I was like, music, like, what concerns music with space? But we're so amazed. By the time she started explaining, wow, it was just like, really? So everything has to do with space. Trust me, everything has to do with space. And somebody said, can astronauts hear each other in space? Yes, they do. They communicate in space. They hear themselves. They even communicate with their control tower on Earth. Yeah, they do hear themselves in space. Yeah, they do. They do.
So on the YouTube channel, somebody says, I saw, how can we apply space science to genetic studies, human karyotype and chromosomes? Okay.
Now, I think the first training we had, it was a lady that taught us on genetic engineering, right? And I think she did the study of astronaut genes before they travel to space and after they travel to space. Okay, after they have returned back from space. So I think what she worked on was that she wanted to see if there was a gene mutation. All right, if anything happened, if there was a gene mutation, did it lead to variation? Did anything actually happen to their genetic makeup and all of that? And she checked all of those things, all right? So I think genetic, we cannot really do that experiment, we in Nigeria now, you understand, because there's no way we can find an astronaut to beg him to give us maybe any part of the body to go and extract gene and all that, you get. So, but I think there are a lot of work online on astronaut genes, yeah, There are a lot of them online that you can just, check out for. I think there's a comparison of before they left and when they returned back. And she did the work on that genetic engineering. I think she was trying to find out how did anything really transpire in the genetic makeup? Did radiation affect it? The gravity issue affect it, and all of that stuff? Yeah. So we can incorporate that when teaching genetics. That's a very powerful one. So the educator could also check on the web, on the internet, and we'll see works that has been done on that. When you get the research work, then you can incorporate it in your teaching schedule.
Fantastic. So many questions. Planting on Mars, sir. How are they getting? Are they getting soil to plant in Mars from Earth?
Okay. No, they don't really take soil from. They don't take soil from Nigeria. Sorry, they don't take soil from the Earth when going. Like we said, like if you do your water culture experiments, like not even soil, what about light? Okay, because they need light for photosynthesis. Okay, so what they do, like we've been taught that you see those lit lights, some are green, some are red. Those have been stimulated to provide light for photosynthesis. And the water culture, if you do water culture, water culture is growing nutrients in liquid medium, right? So all of these things have been used. Like even on Earth, most people don't necessarily need soil to grow crops, currently. They just stimulate it genetically and everything comes up. But in space, they try to see how can we grow crop even in the absence of soil, even in the absence of light. So all of these things are improvised in space in order to make this happen. And we saw things like, I think, pepper and some other, I think, tomatoes, and all of these things that have been grown in space over time. And all of these are things that are currently, going on, and researches are still ongoing, to ensure that all of these are possible. Now, primarily, it's not that these astronauts actually feed on those things over there. These things are done to compare Earth and space. And so far, so good. Things have been grown. So all of these things are done improvisation, as we've been taught. We stimulate that environment to make it happen. Yeah.
Have there been encounters with other life forms, in brackets, aliens, apart from humans in space? I'm guessing this person watches a lot of science fiction. You know that aliens from Mars. Science fiction movies that we watch.
I don't know. I don't think there are aliens in space.
But what about other life forms? They don't necessarily aliens. Maybe Meredith can give us some
yeah, she can. She can help us with it.
to speak with us. Hey, nah, man.
There are no aliens in space.
Do you know that somebody asked, how do they bath? These are questions that, well, there is one NASA live chat series that I was running when they were NASA, where students can get to speak with an astronaut, chat with them in real time. So when that opportunity opens up again, I will communicate it to your district so that we can have some of the students sign up. It's a virtual program too. But thank you so much, Mr. Abraham. Thank you, noble colleagues, for engaging, for all your questions. There are things that we also were asking. Yeah. Meredith is in the building. Meredith is in the building. I hope you have applauded for our state champion. Thank you so much, sir. Thank you. We appreciate you taking time from your busy schedule to attend to us. We appreciate you. Now we have Meredith in the building. Meredith is in the building. That's hydroponic word that I did not hear about, but heard about it for the first time from my student. Meredith is going to do justice to that today. But before, hello, Meredith. Before she comes up, I want to read her profile for us to hear it. So, Meredith, we are super excited to have you join us today. And I'm going to read your profile. Yeah, the live chat on the YouTube channel is buzzing right now.
Oh no. Hopefully good.
They are excited. We are super duper happy to have you join us today.
I'm super happy to be here.
You are powerfully welcome in the name of the Lord, like we welcome our fools. So I'm going to take your profile before you start speaking.
Okay. I have to follow Abraham. He is quite the presenter, so that's a tough follow.
That's cool. So, distinguished noble colleagues, noble educators of the Federal Republic of Nigeria, here we have Mrs. Meredith Swartzendroba. She teaches science to 6th grade students, ages 10 to 12. She has been an educator for 18 years, most of which has been in middle school science courses. She has taught in 4 states in the United States. And for the past 3 years, she has been an educator in a completely virtual school. Do you know what that means? Like in a completely virtual, not physical. Virtual school. Wow. She's an educator ambassador with Limitless Space Institute and works on lessons for teachers around the world to use in their classrooms. This past September, Meredith visited Lagos and worked with Nigerian teachers on space education. She came to Lagos for the first time, and I'm sure she enjoyed her stay in Lagos.
It did.
So, Meredith, make welcome in our Nigerian way. Let's greet ẹ jẹ́ ká kí Meredith pé ó káàbọ̀ sórí ètò wa. Let's greet Meredith. Meredith, ẹ káàbọ̀. Do you still remember that one?
Ẹ káàbọ̀.
Ẹ káàbọ̀.
Ẹ káàbọ̀.
Ṣé dáadáa lẹ dé? You are our people are greeting. Ẹ káàbọ̀. Ṣé ọkọ̀ ò jẹ́po? Ṣé plane yẹn, ṣé fuel ò tán nú ẹ̀? I'm saying, hope the aeroplane did not consume too much fuel.
We're good. So
Yeah.
thank you so much for inviting me to be here today. Like she said, I actually work in a completely virtual school here in Pennsylvania in the United States. I'm actually in my office.
One moment, please. Yes, speak slowly so that we can hear you. Slowly.
Sorry.
Thank you.
I'm used to talking fast for my students.
We want to hear everything you say, so just speak slowly. Thank you.
Okay. You're welcome. So I teach completely online. I teach in the state of Pennsylvania here in the United States. I usually work from home, but today I'm in the office. And in our office, we have a unique facility, and it is an indoor hydroponic, aquaponic garden inside of our school building. I have a club that I work with kids in our facility, and when I present, I will show you some of the things that we have done and talk to you a little bit about hydroponics. But this is our facility. This is not a fake background. This is actually it's about a 6,000 square foot aquaponic facility where we have beds for aquaponics, We have fish tanks off to the side feeding our plants the nutrients. And so we call it Ag Works for our school because agriculture. And we're teaching kids about careers in agriculture and growing things in different ways. So today I'm going to talk to you guys a little bit about growing in space. I know you had a question for Abraham about soil and how do we grow things on Mars. So that ties in with what I can present to you guys today. So I just wanted to share a little bit about my school and our facility. There's nobody really down there right now. There's just a few people maybe back here working. But this is not a backdrop. I feel very fortunate to have this for my students that I can present to them. All right, so I'm going to share my presentation with everybody.
Someone says great and fascinating facility. Very fascinating.
Yes, we're very lucky to have this for our students, and we can grow different things in there. So very, very, very fortunate to have that. So I'm gonna share with you guys. This is not cooperating with me. I'm used to having two screens while I'm working. So I'm going to talk about growing in space and what that is. I have taught middle school science for about 18 years now. Long time. I love this age. They're curious. They want to learn. And I always say bringing space into the lessons really excites them. It gets them wanting to learn more and do more. So I have taken lessons and I have turned them into space lessons. So you already know about me. So when I talk growing in space, what does that look like? What does it look like on Mars? What does it look like on the moon? What does it look like on the International Space Station? So many different ways and opportunities for us to learn and literally grow as we learn more. We can talk about hydroponics and how that can be used in space gardening. How can we incorporate other subjects like math, writing, art, history? How do we bring in other subjects? And then I also have some project ideas that you can do with your students about designing gardens in space. Get them thinking outside the box. But why space? It's fun. I love it. Kids love it. It gets them thinking about what is out there. It creates cross-curricular connections. You can connect with math. You can connect with art. You can connect all across. You can develop critical thinking skills with space science. It engages them in real-world applications and experiments. It promotes STEM literacy or understanding science, technology, engineering, mathematics. And it connects to NASA and future space exploration initiatives. So I bring space into my classroom as much as I can because it opens the doors for them in so many ways. So let's talk about growing. I love agriculture, and I feel like that can connect people around the world talking about agriculture and different methods of growing. In space, it's hard. There's no soil, very little water, especially even on the ISS. How do we grow plants in space. Growing plants on Mars, on the moon, and on the space station are all very different. So this is an astronaut. Her name is Peggy Whitson. She helped grow some of the first soybeans on the International Space Station. They have special grow boxes that have been placed on the space station so that they can experiment. They experiment with peppers, with lettuce, with soybeans. They provide it the light. It provides it with carbon dioxide. It provides it with nutrients so that they can see how microgravity impacts the growth of the plants. So this is just a small little box of how they start doing plant research in space. But when we grow in space, what kind of technologies could be developed? You could pose that question to your students. What do you think we would need to help our plants grow in space? We know that plants need water, need nutrients, they need light to grow. How do we give that to our plants in space? Can these needs be met on a spacecraft? What are some of the challenges? What kind of plants would we even use that could grow in space? These are all great questions to pose to your students so that you can open the discussion and you can have that dialogue with them before you even start, introducing projects or doing things. Have that discussion. Let their brains go wild with ideas. So we need water required for plants, right? They need water to grow. The challenge in space, it's heavy to transport. We can't just load up a rocket ship with water because that means we need more fuel. So we have to be creative with our water usage up in space. We don't have unlimited water resources. Plants need air. They take in that CO2 during photosynthesis. Air doesn't circulate naturally in space. The oxygen released by the plants can accumulate around them because air is not circulated, and it could lead to the plant not surviving unless there are fans to keep the air moving around them. There are other gases also you have to keep in mind inside a spacecraft. Plants need light for photosynthesis. You can use different color lights. Like down here, we've used a little bit more blue lights sometimes to see if it impacts growth. We've used red lights. We've used a combination of the different lights. Spacecraft don't have really a lot of windows. So we require artificial light on a spacecraft. And we want to make sure it's energy efficient. And then nutrients. Plants need nutrients. Lunar and Martian soil has very little nutrients in it. So we must provide nutrients to our plants. But how? Do we bring fertilizers? Do we bring other types of nutrients? Scientists at NASA and other organizations are currently looking for ways to recycle waste to provide nutrients for plants when the soil is not good to grow in. So these are some examples of space gardening that I have done with my students right here in this lab. We have used a lunar soil simulant to try to grow things in lunar soil. It didn't work out very well. The lunar soil is dry. Water will flow right through it. It cakes up. So part of the experiment was to figure out, how can we grow in lunar soil? We had to add in regular soil, continuous watering, and it's still, because the lunar soil is very ashy, it's very volcanic ash, and things don't grow very well in that. We tried growing in a Martian soil simulant. Martian soil, again, is very dry, lacks a lot of nutrients. It is high in iron. So we 3D printed these water feeders for water bottles. You can use recycled materials to create these. So there's a continuous water supply to the plant. We have made our own veggie pillows, which is one of the projects I'm going to suggest to you guys. Veggie pillows are how they grow on the International Space Station. So things aren't floating around on the space station. So students design their own veggie pillows to grow plants. And then I have my rubber duck that is my mascot. And he's always looking over my plants to make sure they're doing okay.
And to make sure that rodents don't attack them.
Yes. I always have my duck. My duck is currently watching over some of my tomato seeds down there. So he's sitting in one of the beds down there watching over my tomatoes. So my kids that come in, they love where Astro Duck is going to be every time.
What's his name?
Yeah.
What's his name?
His name is Astro Duck.
Astro Duck. Interesting.
He's a big duck too. He's like he's a big sized duck.
Uh-huh.
Oh. So hydroponics. That is one way.
The Big Bang Theory we've been waiting for.
What's that?
The Big Bang Theory we've been waiting.
I don't know if it's a big bang, but you know. So how do we grow without the soil? It's hard, you know. In hydroponics, plants are grown in water instead of soil. Nutrient dense soil that is good for growing is hard to come by. We have a lot of soil that we cannot grow in around the world. So we have to look for alternative ways to grow our plants. A lot of hydroponics are set up in greenhouses. Ours is right here. We have a glass roof. We are temperature controlled at about 70 degrees Fahrenheit. Plants are grown year round in here. We donate our food that we grow lettuce and we grow everything. We donate them to a local food bank that goes out to the community, and the food is donated to the community. We raise fish for the state. We grow fish. We're a hatchery, and our fish go out into lakes and rivers when they are full grown. So we work with the community to provide resources. Instead of relying on weather to provide the water, we provide the water. The water is a recycled system. We have what they call a closed system. The water is recycled in our towers. It's recycled in our beds. And it actually uses a lot less water than traditional farming and irrigation. The air is the same as it is outside. We have vents along the ceiling that pump in the air from outside. And the plants bring in that carbon dioxide, processed through photosynthesis, and then the plants can grow. Because plants are grown in water, they don't get the nutrients that they normally would from soil. We add nutrients to our water so that the plants can grow healthy. So we have certain amounts of nutrients that we will add based on how much water we use. So we have towers down here that use less water, so they get less nutrients. Our really big beds that we have down here, those are connected to the fish tanks. The fish waste is pumped through the system into our beds where the plants absorb the nutrients from the fish waste. Our plants basically help clean the water too. It's a system. The plants clean the fish tank, the fish provide the food for the plants. So that is aquaponics, using fish and their waste to provide nutrients to grow our plants. So we do a combination of hydroponics and aquaponics in our facility because we feel we're going more towards, the future. We're looking at how can we provide more food? How can we provide more resources in smaller amounts of space as farmland is less and less? And this is something that we can do possibly on the moon and on Mars. Hydroponics actually saves water since plants don't have to be irrigated and water is recycled. This makes this a very useful agricultural farming method in very arid and dry regions. And I know recycling is a big thing everywhere. We want to recycle and conserve our water resources. We want to recycle materials. Hydroponics can help with all of that. If the land is too dry or any of that, hydroponics will bring the water to the plants. If you don't have a lot of water, it uses less water than traditional agriculture and irrigation. If your soil lacks nutrients, plants need, the nutrients they need are added to the water. If the weather is too cold, like right here, it's been about 15 degrees Fahrenheit for the last 2 weeks here. I'm really cold. Hydroponics can be grown year round indoors. So it lengthens the growing season. Instead of just having one season to grow, you have all year to grow. We're always growing lettuce here. We're always growing strawberries, peppers. And I just planted tomato seeds that actually flew on the International Space Station. My students are growing tomato plants that flew in space. And then we're looking at how they grow and how they germinate on Earth. So hydroponics is a huge benefit. You can start with very simple ways to do hydroponics. Just potatoes can grow root systems in just water. That's a very simple hydroponic project. You just get a plastic cup, fill it with water, stick some toothpicks in a potato, and it can start rooting just by being right there. So potatoes are a really good intro to hydroponic activity that you can do. On the International Space Station, I mentioned the veggie system. It is how they grow in space. The pillows are made of something called Kevlar and Nomex. Those are very expensive materials. But it holds the seeds in there. There's a special grow medium inside, and they kind of syringe the water into there, or else things are going to be floating all over the space station. I did include a video, but in the sake of time, Banke, you have this to share out with them with resources and stuff, correct?
Is it in the mail?
This is the presentation I emailed you, so all of this is in there.
Okay.
Yeah, the link to this video and some other things are in the resources that I did provide to you.
Okay, I'll share it with them.
Yeah. Yes, thank you. So this is a good video to show. It just talks about how they grow the veggie system on the International Space Station and growing in space. So in a little bit, I'll talk to you just about the project that I do with the veggie and how you can do that with your own students. Bringing in other subjects is very important. I know sometimes they're like, this is science, this is math, this is writing. It's so important to teach our students that they all work together. Science and math are connected through measuring growth rates, calculating nutrient ratios with hydroponics, creating growth graphs. Science and writing are connected through technical writing, research reports, and we're connected to other subjects, food sustainability research, art. There are so many kids out there with amazing artistic abilities. So bring that in. Make STEM STEAM. Bring in that science, technology, engineering, art, mathematics. We want our students to experience all of that. And you can do that with growing in space, incorporating space, any of those. Presentation skills. After my visit to Lagos, I have seen you guys have amazing students. They are so smart. And the videos that I see on social media of the presentations are so impressive. I am blown away by what you guys do with your students, by the presentations they make. Keep that up. Those presentation skills are going to take them far. It practices their communication skills. It practices sharing the knowledge. And I have been completely blown away by the videos that I have seen and from when I had my time in Lagos, which I enjoyed immensely. So how do you do this with your students? How can you do hydroponics? How can you do growing in space with your own students? Have them think outside the box. When you talk or teach your students about the basic needs of a plant, take it out of this world. Have them design a space garden of their own. What would it look like? How is your garden going to meet the needs of the plant so it can be sustained on the ISS, the moon, or Mars? You can bring in art and have them draw their gardens and label it. You can have them build it with recycled materials. Again, I know recycling is a big theme. You can have them create their gardens out of recycled materials. I know that was a project I saw at one of the schools in Lagos, was they used recycled materials to build different things. You can do that in designing a space garden. They can practice those presentation and communication skills on how the plant's needs are being met and how they anticipate their garden would help sustain the astronauts. This is just what my students have done over the years. Yes, we are a virtual school. My students are all in their own homes. They use whatever they find around their house to build. I had this one student make her garden in an old packaging of something that her family got. One student made it out of Lego building blocks. Another student used a digital program to design their gardens. But again, you can say, make it out of recycled materials. You can draw your gardens. You can make posters, whatever you are comfortable with in your classrooms. This project is very open and can be done in many, many different ways. The veggie pillow. This is something that can be done, again, to teach students how plants are grown in space. We teach them to construct a veggie pillow. You can use various materials. Find fabrics that can absorb water differently. I used towels, felt. This black fabric is used in gardens to prevent weeds from growing. And we sewed them together. You can hand sew them. You can even glue them. And then on the inside, we put soil. We put different things that plants can grow in inside the pillow. And then we made seed tape. This is like a coffee filter that we used and glued the edges and put seeds inside. So as the seed paper absorbed the water, the seeds got the water they needed. And then so we would just make sure the pillows stayed hydrated, added some water, and then watched our bean plants grow. You can do this with, again, any types of materials that you can find. Basic lettuce, bean seeds. This can actually be simplified very easily. And they can work in groups to design different pillows using different materials. Again, this is a really good recycled material project that the kids can do. In my resources, I have a whole lesson plan on this. It encourages creativity, problem solving, and working together. And again, if you want to bring in that math, maintain a budget and track the cost. You can make up fake costs of the materials, and they have to keep a budget. So that teaches them some math skills too. But it's all up to you to take your students out of this world. Bring in that space concepts, tie it all together, and let your students know that they are limitless, and so are you all. And I thank you for being given this opportunity to be here with you today. And here's the resources that I have that can be shared with you. All right. I think
Awesome.
in the time frame.
Yes, you did. That was a fantastic presentation. Thank you, Meredith. So now we are going to be taking questions. We have loads of questions.
Oh, no.
The teachers are asking loads of questions.
Oh, take it
Okay.
easy on me. Take it easy.
It's an interesting and stimulating topic. I mean, our teachers are just so curious about it. And I can imagine even more so our students. All right, it's question time.
Oh.
Da, 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 da. Drum roll. Get ready.
I'm ready.
So everyone is saying, thank you, madam. Thank you, madam. Thank you so much. Beautiful presentation.
Thank you.
Meredith, well done.
Thank you.
So then we have the first question in here. This question says, could you go over that potatoes activity again? How do we do it with our students?
So potatoes they naturally will grow their own roots. They grow their own root system. And so what I've done to kind of introduce students to hydroponics is just have a plastic cup or any kind of cup, fill it with water, and then you stick toothpicks in the potato I can send it to Banke and she can send it out to you guys as well, include it with resources. And the potato, you set it on the edge of the cup, and then as the roots grow, they go into the water, and it starts to get more roots because it's dangling kind of in the water. So that's just a very simple project. Let me see if I can pull up something real quick while we do that. Potato hydroponics. So let me see if I can just get a simple picture. Yes, I've done it with my students. I send home a potato with my students and we grow it in a cup. So I'm just trying to find a picture. Okay, this is a picture. I'm gonna quickly share my screen so you can see it, just to kind of get a visual. So you can see in a cup, the potato is dipped down into the water, and you have toothpicks kind of propping it on the edge of the cup. And it will start to grow its own root system right out of the potato.
Wow.
Yeah, it's a very simple way you can introduce hydroponics, just with a potato and some toothpicks.
Fantastic. We have another one here. Says,
Okay.
our school land is waterlogged. As the agric teacher, I have been thinking of what to do with it. I have never even known that potatoes can grow in there. Thanks for this presentation. So this person says their school land is waterlogged.
Okay.
What can they do with a waterlogged environment?
Well, like I said, water, locked, they don't have access to a lot of the water, correct?
Waterlogged, like
Oh,
it's waterlogged. L-O-G-G-E-D.
okay. Sorry, I thought you said locked. Waterlogged. So finding just ways to maybe even recycle some of that water, find different uses for some of that water. Again, starting a grow program could be interesting to see how that could help with some of the waterlog. But try those potatoes, and it's a very simple activity that can be done. That's a tough.
All right. Thank you. Let me check the chats on Zoom.
Okay. I didn't see anything in the chat on Zoom.
Yeah, someone just says swampy soil. Okay. If there are any further questions afterwards, I'll channel them to you. In the meantime, before you leave, we usually take a group picture that Meredith was here. So everyone,
I was here.
Meredith came here. So if you can, we would like you to turn on your camera if you can.
Yeah.
And we take this group picture to show that Meredith was here. On count 3, 2, 1, go. I got you all.
I need to come back to Nigeria.
Oh, sure. We will
to
be
come back.
happy to have you come over.
It was the best experience of my life.
You see? That's so cool.
Yes.
Glad
And
that you enjoyed.
I see my friend Francisco is here.
Hey, Francisco Augusto, big Francisco, big Francisco.
Big Francisco.
You know, big Francisco is here. Well done. Well done, Meredith.
Well,
So
thank you so much. I got to go back and teach my students. So everybody have a beautiful day.
Somebody says you mentioned lunar oil. Where is the source? How do you get lunar soil?
It was part of a program called Plant the Moon. And I got some lunar simulant through there.
Oh, they sent it from the moon?
Well, no, it's a simulant. They kind of make up a simulated soil as to what it would be like on the moon.
Oh, okay.
There
Okay.
are there is a site, I believe, through Google where you can also find some, but I'm not sure about where they ship and all those different things. So
we can, if we get that site, we can research around it and improvise with what is available with us here.
I will get that sent over to you in a little bit.
Thank you. Thank you.
Thank you
Welcome.
guys so much.
Thank you, Cheerios. We love you.
Love you guys.
Love you. Àbí báwo lẹ ṣe máa ń ṣe kinní yẹn mi tiẹ̀ kí n lọ́wọ́ yẹn ṣe. Bye.
Bye.
Yeah, make welcome Mr. Francisco Augusto da Silva in the building. Francisco in the building. Francisco Augusto, big Francisco. We call him Big Francisco.
Hello,
Welcome.
everyone. Nice to meet you. Thank you very much for the invitation. It's an honor for me here speaking with you.
Yeah, glad
Today, I
to
will
have
present you activity I make with my students, and they love so much this activity. Let me
Francisco,
see.
slowly.
Yes.
Don't speak fast.
Okay, I will speak more slowly.
Yeah,
Are you seeing my presentation?
it's coming up. Yes, we can see it now.
Okay, so everyone, as Banke said, my name is Francisco. I'm physics teacher. The school that I teach is to rural school. So we have cattle, we produce some lettuce, we have some costs related to the produce food. So I made this activity to my students understand how to preserve food and relate this with the ISS. So my activity is how to use the food conservation to teach the thermodynamics, okay? Okay. So, why this activity is related to ISS? We have a lot of challenges to preserve food in space. The astronauts must live a lot of days, sometimes months on the ISS. So they need to have food to survive this time. As Meredith said, we have a lot of programs to try produce food there. But until this project is not finished, we must take food to space, and this food would last until they come back to Earth. So in space, we have limited resources, so they can plant their own food until now. And they have a limited storage space. So the ISS not so big, and they need to put the astronauts, the equipment, and the food. But not a challenge is this food not only feed them, but have to, not very simple. For example, eating a banana and take the hair skin and throw off. So what we have to do with the waste, of the food waste that we produce? So the preservation of food in ISS, we can simulate here on Earth. Preserved food is something very important. I'm from Brazil. I'm sorry, I forgot to say that. And in my country, until the last government, we had people dying for starvation. And here in Brazil, we produce a lot of food. So one of the problem is the food we produce became rotten before came to the people. So understood how to preserve food is not only a thing to help the space exploration, but to help us now here on Earth too. So the idea is reduce the waste, reduce the quantity of food is became rotten and ensure that this food have a long-term sustainability. So I made this activity, made a relation between conserved food on ISS and conserved food here on Earth. And the idea is simulate some of the challenges they will have on space, and some of the challenges are related here in Earth. So how this activity really works? I'm a high school teacher, so I work this activity on the second year of the high school, because in the second year is when they study thermodynamics, because it's the subject I made relation with this activity. This activity you can make in partnership with the chemistry and biology teachers, and became a bigger one activity with the help, because they can see another aspects of food conservation that I don't understand. For example, they can make relation with fungus or bacteria or another kind of biohazard that can happen in the food, and I don't have formation to explain to them. I make this activity in 3 encounters with my students. The first one, I explain them the activity. I usually take 15, 30 minutes, because the idea of the activity is very simple. The problem is the second encounter, because they will have a lot of questions about the challenge I passed to them. And after we answer this question, the third encounter is when they made a presentation that they list more or less 15 to 30 minutes for team to make the presentation of what happened with the food, what they learned, how to preserve. I will explain more on front. So my activity, I use a strategy called practice of agile methodologies. It's the idea of educational resource where the students became the protagonist of the learning, and the teacher is just someone that is helping them. So I use 2 of strategies. One is learning based on projects. Is when the teacher gives to students a project, a challenge, and the students will learn the subject while they are making this project, while they are resolving a problem. And the second one is the flipped classroom. The usual classroom is the teacher up front talking, writing on the board, and the students watching and writing. So the idea is to flip this. The students will have to research on the library in the moments that they are not in the classroom, and in the classroom where they will make the questions, where they will make the experiments, where they will make the work that they make at home. So the activity is very simple. I go to the class and separate the students in teams. Each team has more or less 5 students. Why 5 students? Because as we have 5 experiments, it's interesting that each student make at least 1 experiment. So the experiments are related to freezing, dehydration by cold, chilling, and frostbite. I will explain detailed each one. The first one, the freezing, each team will take one of those food and put on a freezer. Wait few hours and remove this food by the freezer, and look what happened, explain what happened, how to avoid this. I will explain all the questions in the next slide. But here, this idea is they understand that in space, outside the ISS, it's very, very cold. So they need to preserve food in a way that he can survive those very cold temperatures. And here on Earth too, some people have put some food on the freezer by mistake. Some food don't need to go to a freezer. So the idea is they understand what kind of food go to the freezer, why go to the freezer, and the food that don't need to go to the freezer, how to preserve that, how to preserve it here on Earth and there on ISS. All the food I use here is just a suggestion, because this kind of food is very easy to find at the school, so the students can take and use to make the experiments. But at your school, you can change the food for something that's more easy to find, or something is more cheap to use. That's nothing special in the food that I chose to make the experiments. So the second experiment is dehydration. To understand the dehydration, sorry, just dehydration, they will take one of those fruits or lettuce, and they will put one of that inside the freezer, and another one outside. The previous experiments is related to put the food on the above part of the freezer that is more cold, that the temperature is above 0. The second one is the below part, where we put water, rice, fruits. The idea is they understand what kind of food you can preserve by reduce the temperature, and which food you can do this. For example, banana. Banana is a tropical fruit that to preserve it, you can't put in the freezer. If you put that in the freezer, they will become rotten. So, but most of people put the banana in freezer because they think, oh, the banana will last longer. So that's not what happened. So the idea is they understand what happened with fruits that is inside the freezer and foods that outside the freezer. The third experiment is dehydration by cold. Some food, when is exposure to low temperatures, it will, how could I say, became without water. For example, canned milk. If you don't put the canned milk inside of a recipient, they will lose his water to the low temperatures around the freezer. So the idea is they understand which food you can preserve in contact with the cold, and which you can't, that you must put in the recipient or inside the bag to preserve more this food. The fourth experiment is related to banana. It's related to the chilling, that you put the banana in the refrigerator and another one in the freezer and see what happens with this banana. And the last one is the frostbite. The student picks a small piece of meat and put in the refrigerator and observe how the frostbite affects this kind of food. So the idea is each team will make those 5 experiments with different foods, and they will analyze what happens to these elements, how to preserve in ISS. In the second encounter, they will come to us to ask why this has happened, what is happened, how to preserve this food. In this moment, the teacher helps the students And the third encounter is where they make his lecture about the experiments, how it works, what happened with the food during few days, like you can see in the picture. Those pictures are the presentation of my students. Some groups take the food to the class to us watch what happened with this food. Some others don't, because as it becomes rotten, the smell is not very good, so they throw away. In the second image, we can see what happened with the food during the days. That one of the instruction I give to them. I can send later to Oluwabanke all the activity written that I have here. I will translate from Portuguese to English, and I can send to you next week. I won't forget. So
I'll
in
remind
this
you.
lecture, okay.
I will remind you, because our students need to do this.
So in the lecture, what questions they have to answer? The first one is how they did the experiment. Sometimes the experiment will get wrong because they make something wrong, but that's not a problem. Every way they make the experiment is a way to learn something different. The second is what happened to the food. Became soft, became rotten, changed the color, changed the smell. What changes occurred with the food? You can eat, etc. As I am a physics teacher, I ask them to explain the physics that's behind what happened. But you can make this activity in partnership with chemistry and biology teacher, and they can ask what happened related to the food chemistry and related to biology too. The fifth question is, what's the consequence of the change? So the food lasts longer, less, became rotten, became eatable. The sixth question is, how can they avoid these changes here on Earth? Because I want they learn how to preserve food in their homes and how to preserve this space, because we have to change to send this food to ISS too. And the last one, explain in the cellular level what happened with the food. The water broke up the cell, etc. There is a lot of mechanism that is related what happened to the food in the cellular level that they have to research before make this presentation. So, what's the benefits of this activity? First one is the environmental impact. So if we preserve more our food, we will reduce the waste, we will make our food last longer, and less people will have to become starving. We have the health benefits because food that is well preserved became more nutritional for us to eat here on Earth and there in ISS. We have the economically efficient because if the food lasts longer, we don't need to buy more food. And the global food security, because if as we know, our planet Earth can produce food to feed everybody here on Earth. But until now, we have some people in starvation. So why those people are in starvation? The idea is if you can preserve more food, we will have more food to feed the people, and the food will cost less to us to buy it in the market. I have two bibliographic references that can help you in this activity. This first one, you can find the PDF on the Google. It's related to the challenge of send food to space. If you want to talk more about the space part than the Earth part. And NASA has a challenge related to develop ways to preserve food in space. That is the NASA's Deep Space Food Challenge. So you can adapt the idea of this challenge at the activity if you want, and work this with your students. So thank you so much, guys. I hope I could speak well about my activity, but I will send you this activity right to if you want to make it with your students. Thank you.
Wow, fantastic presentation. Thank you so much. This is superb. And we could hear what you were saying because you were talking. At some point, you started talking fast, but then
Okay, sorry.
it's a very interesting one there. So, noble colleagues, we are taking questions. Can we pump up the chat section with a round of applause? Let's show some love to Big Francisco. Big
Thank you.
Francisco, we're giving you see people are giving you thumbs up. We are giving you a round of applause. Yeah, we're giving you rockets. That was wow. These ideas are mind-blowing. Thank you so much. Right. So now we are
I'm
taking
seeing
questions.
Yeah, I'm seeing here one that says, how long can the astronauts stay in space to conserve food? So this depends of the mission. For example, we had last year 2 astronauts that went to ISS to be there. I don't remember how many days were, but it was between 8 to 15 days, but their rocket had a problem and they stayed at the ISS for 2 or 3 months. So each mission has different time that the astronaut will be in space. So the food preservation is a way to make security too, because imagine if those astronauts became without food. We can't send so easy food to space. So the idea to conserve food is to have I can see an emergency storage of food for situations like that.
Wow. Let's ask questions. Any further questions? The expert is here. Let me go through the somebody says, okay, that was the question you just answered. That
Yes.
can a dehydrated food be rich in nutrients they need? So that brings me to the question of how can we preserve food such that it will still retain all the nutrients that the astronaut will be requiring to stay healthy?
This is a very good question. In my school, we have the technical course of food and we have the technical course of cooking. So I asked some teachers about the nutrients in dehydrated food because when we went to Houston, I bought a small package of dehydrated bananas and brought here to Brazil. We prove it, and I asked them, so this can be food as we know here in the earth? And they said, yes, the problem of the dehydrated food is related to the portions, because as the food has less water, he will look smaller. So you will have more nutrients and more fat, more sugar in small portions of food. So when you eat dehydrated food, you have to eat less than you usually could eat. For example, you can eat in afternoon 3 bananas. Okay, but if you would eat dehydrated banana, you can easily eat 10 bananas, 12 bananas, because the portion is very small. So one of the problems related to dehydrated food is to, as we can say here in Brazil, to fill our stomach.
Awesome. How are foods sent to the astronauts in space? How can food sent to the astronauts in space be preserved from spoilage?
Preserve from spoilage. What is spoilage?
Like from spoiling, from going bad,
Yeah, okay.
from going
Well,
bad.
when we were in Houston, we saw a little about this in the tour that we did in the Space Center Houston. Do you remember? They show us that the food go to the space. They make some process like pasteurization to kill any bacteria that could make the food to spoil. And they remove most of the water of the food to have no chance of the spoil in the travel. And we saw the bags where they put this food to survive the lifting here for us until there. And when they are there, to eat, they put this food in a machine where the water is put inside the food to become more delicious. There is a video. Let me see if I can find it here now. Where show the astronauts eating the food in the space and how do they do to rehydrate the food. Let me see if I find it. Just a minute. I will search here because I remember I saw this video, but I'm not finding it right now because this video was in one of the activities that we did that the the LSI. But I will send to Oluwabanke that the video is very good because they show how this process to hydrate food works.
Fantastic. Thank you so much. So someone was saying that the link, did you share a link in your presentation?
Oh, yes, a link for NASA Food Challenge.
But it's the NASA Food Challenge. Is it part of your presentation slides?
Yes, I will send here on the chat.
Okay. Let me copy it out for them. So the link has been, I will send it to us on WhatsApp, and you'll be able to, there are a couple of other links too. So by the time we are done, I will send it to you on WhatsApp. Okay? So
okay,
are we seeing other questions? Questions? Can we feed on foods while on space? Somebody is asking, can we feed on foods while on space?
Oh, sorry, the audio cut it. I don't listen the question. What was the question? Sorry.
The question says, can we feed on food while in space? Or better say, maybe the person just wanted to ask, what kind of food do they eat in space?
What kind of food? Scrambled eggs, the shrimp cocktail, usually any kind of food, natural, like lettuce, vegetables, fruits. Usually they don't send foods that will have some kind of problems like bread, because bread, the dust of the bread can, how could I say, be inside the equipments and destroy it. So food that can throw this dust, how could I say dust? You can send, but fruits you can send, vegetables, rice, beans, cooked food in general, you can send to space.
The last time we were in Houston, they said that the astronauts, they lose their sense of taste for pepper. So they usually would like spicy food. Do you recall?
Yeah, it's very interesting because here in Bahia,
Because they
that's
have
my
spent
state,
so long there, so their tongue taste buds tend to lose activity, right? So
yes.
astronauts, they eat, they are human beings, they are alive, and it's all part of our functions. Mr. Niger D, living things move, nutrition. So they will eat definitely. The fact that they are in space doesn't mean they don't eat food. So someone asks, is there a drug emergency for the astronauts in space?
Yes, there is, because if astronauts have an ill, they must to treat them in the space, and they only come back to Earth only in high emergency situations. So yes, they have some emergency drugs for the astronauts on space.
Okay, and the final question, because we can get questions coming, the questions will just keep coming. Okay, so the final question, how do they cook food in space, with gas or fuel? Or are the foods already cooked before sending to space? How do they cook food in space? Is it with gas or fuel, or are the foods already cooked before sending to space?
No, they don't cook food in the space because would be very dangerous. So the food is already cooked here on Earth and then sent to space. But there they have some machines that make the food warm using microwave or using electricity, like oven, electric oven, to make the food warmer and more delicious, because nobody likes to eat old food.
And then you talked about dehydration by cold. I've never heard that before. Dehydration by cold as a means of preserving food. Can you share more on that? Does that work? Like, you can actually dehydrate something with cold?
Yes, if you look at your refrigerator, you have to put the food in the closed recipient, because if you get open, this food will lose water to your refrigerator inside. So usually this is not a very huge problem to preserve food, but the taste is not very good. So For example, I make this activity with a candy bar. When you put the candy bar inside the refrigerator, we use usually banana candy, and the sugar will blow up outside the candy. The candy will become a little whiter, little white spots. That's the sugar. And the taste is not very good. The candy bar is rotten? No, but the taste is not very good. The problem related to the food opened inside the refrigerator is not the temperature. It's related to bacteria. So as the air circulates inside the refrigerator, your food can be contaminated with those bacteria. But related to the temperature, no, the food will not spoil, but will not become very tasty.
But dehydration is like removing water.
Yes,
So
because
what
the
I
process is to because the difference of temperature, the flow of heat is related to the water. So the water that is inside the food, it go to his surface because of this change of heat, and the food became with less water because the water inside the fridge will slowly it's not boil. They slowly will go out from the food. So, for example, in a professional restaurant, every food inside the refrigerator are inside very well closed recipients because it will keep the food more tasty and how could I say, softness will remain the same. For example, if you take a cookie and put inside the refrigerator with nothing, they will become soft. If you put this cookie inside a closed recipient, the cookie will remain hard, will remain with the same aspects that he was when you opened the bag where the cookie was.
Wow. Wow, thank you so much, Francisco. That was a fantastic presentation. And thank you
Thank
for
you.
answering all our questions. We appreciate it. So is that fun part of the presentation when we take a group picture to show
Okay.
that Francisco Augusto, big Francisco, was here. Big Francisco was here. So if you can turn on your camera, it's my favorite part. It's my favorite part. I want to look at these pictures later on and say, oh, I saw you. Oh, I saw you. So I'm going to count 3, 2, 1. Take in. Thank you, Francisco, for coming. We appreciate
Thank
it.
you.
We've learned a lot. So I'll look out for your email with the presentation items and the resource links. And as soon as I get them, I will share it with my colleagues. Okay? So thank you so much.
Okay.
Enjoy the rest of your day. Cheers.
Thank you. Bye-bye, everyone. Here in Brazil, it's 12 o'clock, so I will have my lunch.
Okay. Cheers. Don't get dehydrated.
Okay. Bye-bye.
Bye. Cheers. Okay. And on that note, we have come to the end of this part of the training. You have heard a lot. So, do you have any feedback, any responses? Is there anything you want to say? Is anyone saying anything? Ah, well done, everyone. Well done. You all have been wonderful. Sticking through. It's been a lot, and I know you've gotten enough ideas to take back to your classes. Yes. Okay, so in the absence of any we don't have any, do we have anything to say? Okay, so you will be able to unmute now, and then you can share your experience for this first part of this training and what your action points will be going forward from here. So we can quickly do that. Can we quickly do that? Who's speaking? Adeshoko Florence? Yes. Okay. Any comments? What are you taking back to your class? Which of the presentations is the first you are going to implement? Okay. Ooh, it's been a long day. We want to give God all the glory for the help and the grace He has granted us thus far. So, in the absence of any questions, comments, can we take our group picture so that we can get on with the rest of the day? Does anyone have, if you can turn on your video. It's that favorite part for me when I get to take pictures. I love to take pictures. I can take pictures for Africa and win the gold medal at the Olympics. Yes.
Adeshoko. Alájà, ẹ kú training o. Ẹ kú gbádùn o.
Àwọn
Ó
tún
kúkọ
jọ
fún wa lóúnjẹ
nífẹ̀ẹ́.
báyìí. Oúnjẹ
Ó tọ́ mà ní.
Ó yẹ ká ẹ wá refreshment.
Ẹ jẹ́ kí n bá yín dehydrate omi yìí. Kí n bá yín sílẹ̀ ilẹ̀.
Ẹ gbé wọlé pace kó wá deliver fólúkálùkù.
Ẹ ká sọ ẹ jọ̀ọ́ mà èmi ò sí ní WhatsApp group o. Mi dẹ̀ mọ̀ bí mo ṣe máa join.
There is a form tẹ́ máa ti register.
Mo fẹ́ register but mi ò ní registration number. Àwa ò tí wà confirm so mi ò ní. So mi ò rí registration yẹn ṣe then. So mo dẹ̀ complain ní WhatsApp group o principal wa bọ̀.
You are a baby teacher. You are a baby teacher. You are a baby teacher. Baby teacher ni ẹ.
Ẹ má wọrí.
So mi ò rí so mo tẹ̀ complain mo try gan but kò lọ so.
Alaye stop complaining. You are a baby teacher.
Mo join méjì ní YouTube then ẹ̀kan ní orí Zoom lẹ́yìn. Ọ̀gá mi.
Ṣé a ti ready fún picture wa?
Yes.
Yeah.
Lójú mi hàn báyìí.
Sorry. So on my count, It's trying the best course. I know that I am a fanatic Nigerian. My national anthem wa lè ní ṣó dẹ̀ dábẹ́.
Ebi ń pa wá, ebi ń pa wá, ebi ń pa wá.
Wíwí ẹni gbogbo oúnjẹ tán fún wa yìí. Tán tún kọ́ wa bá ṣe máa preserve oúnjẹ.
Oúnjẹ mi nìyẹn tara là ń béèrè.
Oúnjẹ space nìyẹn.
Okay, Max. So I will count 3. Let's go. 3, 2, 1. I'll take one more. Àwọn kan ò fẹ́ yín sí wa o.
A fẹ́ yín o, a fẹ́ yín o.
Fẹ́yìn o. Mrs. Aládéjọbí. Bàbá Àkálẹ̀ mo ti réyìn yín. Mrs. Aládéjọbí mi réyìn yín o. Mr. Ọlájà.
Àwọn ti ṣe.
Orúkọ tèmi o.
3, 2, 1. 3, 2, 1. Okay, I got you all.
God bless you.
Thank you, ma'am.
Thank you, ma'am. Thank you for the wonderful experience. We enjoyed it.
It's 9 o'clock. The Lord is your strength. Thank you so much. God bless you.
Thank you. God bless you.
Thank you. God bless you. Bye-bye.
We all love you.
It's
nice meeting you, ma'am.
Love you all.
Nice
Thank
love you. We love you too.
God be
Have you finished?
I'm going to don't like my status.
As in, can you see me doing?
Kò ní ìdíkì wọn lé náà.
Ṣé yà sí mi? Ibi tó yẹ tèmi tọ́pẹ́. Oh Lord.
Mrs. Adeyemi. Hi. I'm so worn out.
Anyhow. Bàbá Àkálẹ̀.
Oh, wow, it's not easy. Bàbá Àkálẹ̀ ṣá, ó ṣá ń fẹ́ yín ni. Àìsàn oúnjẹ.
Bàbá Àkálẹ̀. Ni máa mú ọmọ tó ń pè lórí ẹ̀
God bless you, ma. Ibi tó yẹ thank you, ma. Adeyemi, God bless you. God bless, ma. Thank you. Bàbá Àkálẹ̀ school wo lẹ wà?
Akérèmí Express Senior Secondary School, Tolu, Ajegunle side.
Ẹ̀yin ọmọ orí omi.
Àwa ni.
Ẹ ra màmá mi. Ẹ bá àlàáfíà ni mà.
Ẹ̀yin gangan lọ́ṣà hydroponics.
Ẹ bá wọlé àwọn ọmọ akẹ́kọ̀ọ́ ẹja ní space. Wọ́n bá wa dé ọjọ́ yìí.
Ẹ máa tètè máa lo hydroponics fún wọn dáadáa.
Ẹ̀yin ọmọ ajẹja.
Apẹja yanja.
Àwọn apẹja yanja.
Máa sẹ̀ǹdẹ̀já sínú.
Ìlànà ọmọ ayọ̀ ẹja báyìí.
Ẹ máa jẹja.
Wọ́n ti sọ fún wa pé oven wà ní space. Electric oven wà ní.
Everything ló wà space. Solar kò bá tiẹ̀.
No.
Only limited
That one
resources.
is not in space. All right, ma. Bye.
Yes.
Okay. Thank you very much, ma. We love you. Bye. God bless, ma. Wish to meet you again. We love you.
I will communicate on the WhatsApp.
Please, some of us were unable to join the WhatsApp group.
Yeah, you can just send me a message, but I've received a lot of messages. I've not gone through some of them yet, but you can send me a message and I'll try to respond as soon as possible.
Màmá òun mo ti máa send message sí yín báyìí. Mi ní contact mi.
Okay. Ẹ bèrè lọ́wọ́ àwọn colleagues yín tó ti wà nínú group yẹn, tán ti successfully join. Pé kàn share link tẹ́ máa fi register yẹn pẹ̀lú yín. So tẹ́ bá ti dé point tí
registration number.
Ẹ kàn kọ RGRPPP 0000.
GRPPP 0000.
No, but like me, I was able to. Hello, like me, I was able to register successfully, but I did not get to that. I did not see that icon to join the link.
It's there. So maybe you just
So
feed
when
it.
I went back to check, it said it's closed.
It's not, that one is not the registration form. Oh. That one is for evaluation of speakers.
No, the one that was out for us last week. Is that not you, the one we were talking about?
Yes,
The one
it's
that
not
we were
closed
asked to
yet.
register with last week.
It's not closed yet.
It was closed since Monday. Was it reopened?
No, it's not. It's not.
So we can re-register again, even though our details are there.
Yes, you have to register again. That would be like another fresh submission.
Okay. Maybe I'll try that again.
Yes.
All
All
right,
right,
fine.
thank you.
All right.
All right.
Bye, everyone.
Bye.
Everyone. Bye, everyone.
Bye, ma.
Bye.
Cheerios.
Right here.
God be the glory.
Olu.
Yes, that's register again. That would be like other.